sought IT program, operational research conducted by various professional bodies. She is resource person for several workshops on epidemiology and biostatistics, and her area of interest are operational research, epidemiology, preventive oncology, and tuberculosis. Over to you, ma'am, Dr. Vijay Geeta.
Thank you so much for that wonderful introduction. I'm just sharing my screen. Is my screen visible?
Yes, ma'am, visible.
Am I audible?
Yes, ma'am, you are audible.
Yes. At the outset, I would like to thank the organizers, Dr. Kripal Joshi and the team, as well as Dr. Ranjan for giving me this opportunity to present on the topic. And I congratulate you on conducting this national effort on CME research methodology. Okay, so without further ado, I would like to move on to the session. So good afternoon, everyone. So this is another session that, another very important topic that you would be learning about. So before we actually move on to the topic, there is a small scenario that I have written it down. So we can just go through this and then we can move on to the important concepts about bias and confounding. So let's imagine a new drug that has been developed to treat blood pressure and it has gone through clinical trials. The trial results show that the drug works very well for most of the participants. However, after a few years later, it turns out that the drug is much less effective and even harmful for women because the majority of the participants in the trial were men. So why did the trial results predict this outcome? So there may be two questions that we may have in our mind. One is, what might have gone wrong in the research process and could this problem have been avoided, and if so, how? Right? So I would give you can think over this question and then we will move on to the session. Yes? So what might have gone wrong in the research process? They very clearly stated that majority of the participants in the trial were men, which means the women were underrepresented in the trial, and therefore, probably they were not able to produce valid findings for the valid findings pertaining to gender-based distribution. And how this problem could be avoided? Very clear that they could have had better representation of women in this. Okay, so this is where the context of bias comes in, where we are talking about the validity of the findings. And whenever there is any kind of bias in the study, here it was a selection bias because of the differences in gender. And whenever there are any forms of bias, it definitely either underestimates or overestimates the findings of the study. So these are the learning objectives for my session. First, discuss about bias, then about the different types of bias, the different methods for addressing the bias, what is a confounder and what are the characteristics of confounders, and how do we address confounding. Okay. So coming to what is bias. So bias is basically a systematic error in the design, conduct or analysis of a study that results in a mistaken estimate of an exposure's effect on the risk of disease. So what we mean by systematic error here is something that is non-random, that occurs time and again. Okay, it could be because of the way in which we measure, or it could be because of the way in which the sample has been taken from the population. And bias definitely undermines the validity of the research because the findings are going to be again overestimated or underestimated, or it could change consistently, and it causes deviation from truth, and therefore it is very important to look for it. So there are different ways of classification of bias, but in this context I would stick to classifying them as selection bias and information bias. So now let's look at what is selection bias. So let's say, I were to pick up two fruits and we were comparing apples with oranges, right? So we could look at whether they are similar. So similarity in terms of both of them are fruits. However, they are again different as well. So the apple is red in color, orange could be, is orange in color. The texture of the fruits may be very different, right? Or, if you look at the nutrient point of view, the nutrient values may be very, very different. So now the question here is, instead of apples and oranges, if I were to take people with different characteristics, would that mean that they would be comparable? So it is always better to take people who are comparable, so that we are able to get valid findings and we are able to make meaningful inferences out of that. So always compare individuals who are having similar characteristics. So this is where selection bias comes in. So arises in the process of identifying the study population. So particularly it is a problem with case control studies during the selection of cases or controls, when we do not define cases and controls explicitly and accurately. So the different characteristics between the exposed versus non-exposed or responders versus non-responders may introduce this kind of bias, that is selection bias. Example, so there was a study done by McMahon et al. Okay, so in which the controls were selected from a group of patients hospitalized by the same physician who had diagnosed and hospitalized the cases as well. So the controls often had gastrointestinal disorders and were thus advised not to drink coffee. So this led to a spurious positive association between coffee intake and pancreatic cancer. But in reality, if you compare this with the general population, the coffee intake could have been very different. It was because of physician advice or because they had a gastrointestinal problem, they refrained from taking coffee, and therefore there is an artificial overestimation here. So next, we have different types of subtypes under selection bias. So one of them is called a volunteer bias or a non-response bias. So for example, if we start a study and we want to look at healthy behaviors, okay, those who might come or approach us may have very different characteristics as compared to those who may not approach us. So one example is if you want to determine the prevalence of HIV infection and we propose voluntary testing, so we may find that there are no HIV positives. So is it correct to conclude that there is no HIV in the population? May not be the case, because there is another concept that may involve here, which is called a social desirability bias. Okay, so the social desirability bias is the tendency of respondents to reply in a manner that will be viewed favorably by others. So this will lead to either over-reporting good behavior or under-reporting bad behavior. But in contrast to this, when a patient comes to a physician and you're asking, do you smoke or do you consume alcohol, by virtue of fear of the physicians, or they want to be in a good place, or they want to say that they follow a certain positive behavior, they may refrain from actually reporting these kind of uses, and which may adversely affect the outcome of interest. Okay, but in contrast to this, CAPI is basically computer assisted personal interview techniques. Sometimes because it is virtual and people are more comfortable answering virtually, people tend to sometimes rightly answer to the questions, or it could also be the other way around. So this is called a social desirability bias, which we need to have in mind when we design the studies. The next one is healthy worker effect. So it is most commonly used in occupational epidemiology. So the idea here is when somebody is under observation, they tend to perform. So the classic example is by Dole et al. They compared the standardized mortality rate among coal exposed gas workers versus the general population. So contrary to the expectations, that standardized mortality rate among high-risk population was less, that is among coal gas workers was less compared to the general population. What they then did was they again stratified and found out how many of them within the coal exposed gas workers were heavily exposed, then were moderately exposed or intermittently exposed, and how many of them were exposed comparatively lower, and then they took a call on it. The next one is called as Bergson's bias. So it arises when samples are not drawn from the general population but from the subpopulation. Let's say we tend to take controls from the hospitals itself, but who do not have the same outcome. So case control study looking at the association between OCP use and DVTism. So let's say the physician already knew the possible link between OCP usage and DVT. So they would suggest so any women with suggestive symptoms and no use of OCPs are more likely to be admitted by the physician, and this in turn could lead to an overestimation of the effect. Okay, so these are all about selection bias. These are just some types of selection bias. Now moving on to the next concept, which is the bias. So this is a bias in obtaining the needed information about exposure or disease status. So when does it arise? It arises when the means of obtaining information about the subjects in the study are inadequate. So as a result, what happens is regarding exposures and or disease becomes incorrect. Okay, so these are some of the types. So one is called as Hawthorne effect. So people actually act differently if they know they are being watched. Okay, so this was a classical effect. Like let's say we want to do a study about diets, and we want to do a trial on a community-based trial on dietary factors, and we want to see the risk of cardiovascular disease. And there are two groups, that is the intervention group and the control group. And in one group you give a very specific dietary regimen, in the other group you allow them to follow whatever is the standard consumption that they do. What happens here is, by virtue of involving in the study, by virtue of being a part of the study, the individuals may change their behaviors or the dietary consumption. Probably they may have less trans fat or less saturated fat, adapt to more plant-based diets or something, a healthy form of diet, which in turn may adversely affect the findings of their study. The next one is called as surveillance bias. So the group with the known exposure or outcome may be followed more closely or longer than the comparison group. Okay, so here we will talk about surveillance bias in the coming slides as well. So another way of looking at it, misclassification bias. So what is misclassification bias is, whenever we categorize them, so there are errors that occur. So errors in categorization of either, it can either be because of the disease status or it could be because of the exposure status. So this categorization that we do, it could be either a random categorization or it could be a non-random categorization. So random categorization is otherwise called as non-differential misclassification bias, and when it is not at random, it is called as differentiation bias. So the surveillance bias that we discussed in the previous slide, right? So when we know, like let's say an investigator is trying to look at the outcome, and if they know about the exposure status, okay, they are more likely to ask, closely to do investigations, or closely to, more frequently ask questions and try to do an outcome assessment as compared to in the control group, right? The exposure assessment in a case control study, when we are talking, if the investigator or the one who is assessing knows that the person is a case or a control, they are more likely to look at the exposure status in cases as compared to control. So this difference between assessment in the different groups is called as differential misclassification bias. And the other thing, which is random. Random means like there is a field worker who goes a specific topic about outcome status, and consistently, irrespective of whether they had an outcome, did not have an outcome, they are going to consistently ask this question in the same way, but it's also going to affect the validity of the findings. So it may be incorrect way of measuring, let's say using a weighing up test, incorrect way of measuring blood pressure using a sphygmomanometer, or incorrect way of putting up a question so that the validity of the findings may get affected. So that happens not just in one group, it all happens consistently in both the groups of participants. Okay, so here we have an example of differential misclassification. Women who had a baby with a malformation tended to remember more mild infections that occurred during the pregnancies than mothers of infants without malformations. So probably less likely to remember a mild infection during pregnancy. So what we call as recall bias is basically a subtype of differential misclassification bias as well. So those, it may be very difficult to recall events or exposure in the past for those who have not had an outcome of interest as compared to those who have had an outcome of interest. And again, we have to look at the time lapse between exposure and recall. So that for the duration was like before a year, before 2 years, before 3 years, or it was an ever user or had an ever history, then that may significantly affect the results. So non-differential misclassification, we again saw this. So it is basically because of problems that are inherent in the data collection methods, and it's the usual effect of non-differential misclassification is that the relative risk or the odds ratio study design, it tends to be diluted, and it usually starts shifting towards the null value or 1. So next is coming to interviewer bias. So interviewer bias is basically something that is dependent on the knowledge of the interviewer, okay, about the research question, and that may influence the structure as well as type of questions and the manner of presentation, which may influence the responses. So observers should ideally be blinded to the exposure and disease status of the. So we have an example here pertaining to breast cancer and alcohol use. So interviewers who had to ask about the history of, history of alcohol intake, and interviewers were blinded to the case or control status of the individual. So this would ensure that there is no interviewer bias, and among both groups, the questions are consistently asked to find out the exposure status. Another type of bias common with cohort studies or even randomized control trial is attrition bias or loss to follow-up bias. So those that are lost to follow-up may be different from those that are followed up for the entire study, and this is very important to keep in mind, and that is why in case of randomized control trial, we don't stop with intention to treat analysis alone, but also go for something called as a per protocol analysis. So how do we control for bias? So one way of doing it is blinding. So blinding, again, we know it can be different types of blinding. It can be single blinded or double blinded, or it can even be triple blinded wherever it is possible. Then strict a priori definitions, so accurate definitions or clear distinctions between who is a case, who is a control, and who is what is considered as exposure status and non-exposure status will avoid any type of misclassification or minimize the risk of misclassification. Then proper training for data collectors is very, very, especially a lot of measurements, a lot of questions are asked by the data collectors, and therefore consistency with the questions and consistency with the way the measurements are taken is very, very crucial. The next one is to build in methods to minimize loss to follow-up. So when we have to anticipate what would be the response rate or what would be the loss to follow-up for a particular topic, and you have to incorporate mechanisms. It can be in terms of telephonic reminders or engaging people in the community. It could be a family support system that again reminds them, or there are multiple other automated reminders as well, which could significantly reduce the loss to follow-up or attrition. So the next thing is, before we move on to confounding, is I would like to stress upon some biases that can occur with a randomized control trial. Okay, so as we discussed, it could occur at the stage of the study. So it could be at the stage of conceptualization, or it could be at the stage of designing the study. It could be at the stage of conduct of the study, or it could be at the stage of reporting, or more commonly, at the stage of dissemination of the study. Okay, so all of this we will look at it in the context of a randomized control trial. So selection bias, yes, it could occur, but most often, since randomization is considered as the heart of the randomized control trial, this randomization, there is equal chance of a person being allotted into intervention arm or a control arm, and this takes care of any kind of selection bias that could occur. And allocation concealment also will help to a certain extent in eliminating selection bias. The other next one is ascertainment or outcome assessment bias. This can again be minimized by blinding the individuals. It could be the allocator, it could be the statistical analyzer, or it could be even the one who is in the initial parts of the study. And attrition loss to follow, but discuss about it. The next one is selective reporting bias. Okay, so selective reporting is like whenever we have a positive finding, only those are being reported, or whenever this is more like where inherently as investigators we may have some facts that we want to prove, or we may be inclined to certain findings, and we may selectively report those. So that can be minimized by trial registration. Now in India it is mandatory that all trials have to be registered under the clinical trial registry. So that also ensures accountability and reduces bias. And the other one is publication bias. So publication bias is like publishing only positive findings. Okay, so which means so there are ways of looking at whether there is a publication bias pertaining to a particular topic, or whether all sorts of studies are published, irrespective of whether they come up with a positive finding or a negative finding. So part of the presentation. So this is about confounding. So what we mean by the term confounding, sometimes they also call it as confounding bias. Okay. So, but what we mean by the term confounding essentially means mixing of effects, or we can say it as a confusion of effects. Okay. So we have an exposure and we have an outcome, and the apparent effect of the exposure of interest is distorted because of the effect of a third factor or a factor. So this third factor or an extraneous factor is nothing but your confounder. So what happens is the distortion can lead to either overestimation, or it could lead to an underestimation of the effect, or it can even change the apparent direction of an effect. Okay. So I'll give you a simple example. Okay. Let's say I want to go buy hats. I go to a shop. In a table there are 5 hats. So I try to fit each of the hat to my head, and I observe in table 1, one of the hats fit me. Okay. Now I move to table 2, and I observe that 2 of the hats are actually fitting my head. Then by then it is time and the shopkeeper closes the shop. So again I have to go back the next day to see. So there are 2 more tables where there are hats. Okay. So table 1, table 2, table 3, table 4. Let's assume table 1 has black hats and table 2 has red hat. So now in table 3 again there are black hats, and I see that 4 of the hats actually fit, and in the table 4 where there are red hats, only 1 of them fits. So what was my conclusion initially? That table 2 or red hats were more fitting as compared to the number of red hats fitting my head were more as compared to the black hats, right? But when we actually look at the target population, that is table 1, table 2, table 4 in entirety, it may be very different, right? So at the conclusion, 4 of the black hats in table 3 were fitting my head, plus if I include 1 in table 1, it is 5 hats out of 10 were fitting my head as compared to 3 hats from table 2 and table 4 that are currently fitting my head, right? So this change in the effect, or change in the direction of the effect, from 50%, okay, from 10% it moved to 50% eventually, and initially for red hats it was like around 40%. It actually changed to 30%. So there is change in the effect. So this could happen when there is a third variable or an extraneous variable. Okay. So when do we have to bother about confounding? So when we don't find an association is basically a relationship between 2 variables. Here the variables are basically the exposure variable and the outcome variable. So whenever there is no association, we need not have confounding. But when there is an association, we need to see whether confounding is present or not. So confounding matters in studies that attempt to show that an association between a predictor and an outcome is causal. Okay. So confounder, as we know, it is a variable that is that has certain characteristics. Okay. So it produces some kind of a mixed effect, or it distorts the effect, the association between the exposure and outcome. Okay. So there are 3 characteristics for a confounder. So one is it has to be associated with the exposure. The second is it has to be associated with the outcome. So association does not always mean causation. So for causation there are several other criteria defined by the Rajkot criteria. So it needs to satisfy all of them. So but it needs to be a confounder, it needs to be associated with the outcome. It can independently produce an effect on the outcome, and it must immediate step in the causal path between exposure and outcome. Okay. Let's say there is a molecular change that happens, or a physiological change that happens before there is an effect, then that becomes an intermediate variable. We'll see it with some examples. Okay. So a study finds that people who carry matchboxes are likely to get lung cancer. So what do we say? Is the association between carrying matches and lung cancer causal? Is the association confounded by something else? Right? So we have two variables here. One is carrying matches, which is a predictor variable or exposure variable, and we have the lung cancer as the outcome. Right? So but when we look closely, we see that those who carry matches actually smoke cigarettes, and if you smoke cigarettes, you are likely to develop lung cancer. represent the same thing in a 2 into 2 table. Okay, so CA here is for lung cancer, individuals with lung cancer, and here it is individuals who do not have lung cancer, and we have in the exposure status those who carry matches and those who do not carry matches. Let us assume in this study, 1000 cases of lung cancer are taken and 1000 controls who do not have lung cancer are taken. Okay, so let's assume that 82% of those with lung cancer matches, okay, or a lighter, and 34% of controls carry matches. So can we calculate the odds ratio for this? So odds ratio is basically a cross product ratio, right, where we have the concordant boxes in the numerator and the discordant boxes in the denominator. Okay, so this is how it would look like, right? We have around 820 of those with lung cancer who have matches, and we have around 380 of those without cancer who have matches, right? So if we calculate the odds ratio, AD by BC, 820 into 660 by 180 into 340, we would get roughly around 9, that is 8.849. Okay, so what does it mean? Carrying matches increases the risk of lung cancer almost 9-fold, right? This may be an interpretation. So what's the problem here? So it is absolutely true that people who carry increase risk of lung cancer, but again it is not true that carrying matches causes lung cancer, right? So what's happening here? Let's see, we were thinking about a third variable, which is smoking here, right? So let us stratify by exposure to the confounder. So can we classify them as, can we look at the odds ratio among smokers and non-smokers separately? Yes. So if we were to do the same thing, we see that the odds ratio, this is 1, and similarly the odds ratio among non-smokers is 1. Okay. So what does this mean? That there is no association between carrying matches and lung cancer in smokers, and there is no association between carrying matches and lung cancer in non-smokers as well. So thus, the association between carrying matches and lung cancer is completely confounded by a third variable or extraneous variable, which is smoking here. Okay. This is another Longnecker et al. In a large case control study in 95 proved that alcohol consumption was associated with the risk of breast cancer. Okay. So the author said, confounding seems an unlikely explanation for our results. Some presently unknown risk factors may confound the results. Okay. At that time when the study was done, dietary risk factors for breast cancer were unknown and thus were not accounted for in the study. Okay. So what do we do? Right? So alcohol consumption here was the exposure and breast cancer is the outcome here. So the third variable or the extraneous variable here is a saturated fat intake, which is a confounder. Right? So if we were to calculate, again, we stratify in terms of saturated fat intake and we find that the odds ratio is similar in both the categories. What does it mean? That there is no association between alcohol intake and breast cancer, right? So another example again, population-based case control study found that ever use of alendronate was associated with an increased risk of incident atrial fibrillation, right? Since osteoporosis affects older people who are at higher risk of atrial fibrillation, subsequent studies adjusted for age and demonstrated that no evidence of an increased risk of atrial fibrillation was associated with alendronate. Okay. Every study will have some biases, every study will have some confounding. So we looked at methods for addressing biases. So now we will look at methods for addressing confounding. Okay. So we can do it at the design stage itself or at the analysis stage. So there are different methods. So one of them is restriction, the other one is matching. Then we have randomization in randomized control trials. And if this was all not possible, then at least in the analysis we could still stratify like what we saw in the previous example, or we could do a multivariable analysis using regression. Okay. So what do we mean by restriction? So it is potentially confounding where it is restricted from varying. So how do we do this? We can do this by either selecting a restricted age group. Let's say we want 30 years, we could just select, those individuals between 40 to 50 or between 30 to 50, right? So what essentially happens is, the idea here is that above 50, the risk of cardiovascular disease is much higher, so more likely, more people are likely to have that. So let's just focus on 30 to 50 years age group to look at what is the risk of acquiring cardiovascular disease. But what happens is, it shrinks the pool of available subjects, right? And we may not be able to generalize the population other than what has been studied. So next, coming to matching. So matching, essentially we do it in case of case control studies, right? So we potentially look for confounding. So we may know based on previous literature that some of these factors are confounding factors. These are known confounding factors, and there may be again unknown confounding factors, right? So we can try to match for known confounding factors. So this matching can either be individual matching, that is one-to-one matching. So this was published sudden acute death study where many institutes from around India participated, right? So what did they do? So they looked at any let's say there is an individual 40 years old male who had died passed away because of sudden cardiac arrest. Then they would try to find similar controls, similar neighborhood controls, okay, within 1 kilometer vicinity. They would try to identify with minus 5 years age group, okay. So you may not, many times it may not be possible to find exactly the same age, exactly the same gender, exactly the individual with very, very similar characteristics. So it becomes very complex when you try to match for many, many variables, right? So this is about individual matching. The same thing can be done as a group as well. So how do we do group matching? In the study, we can assume around 50% of my population or 30% of my population should be above 60 years of age, 40% of my population should be between 30 years of age, and the remaining should be from the rest. Okay, so this way, it is also called as frequency matching, where instead of matching for one-to-one individual characteristics, we do a group matching, which also will try to address the problem of confounding. But again, will it completely eliminate or minimize confounding? No, there is still a possibility of residual confounding when we do group matching. So the next one is randomization. So we should create groups that have equal propensities for the outcome. So randomization is an attempt to evenly distribute the potential for known and unknown confounders in study groups, but it does not guarantee control of confounding, right? To a certain extent it is possible. Then again we have to do an analysis and check whether the groups were very similar in terms of their characteristics or not using certain tests of significance. Then we will be able to know with hypothesis testing. This is control during analysis. So this again we learned about stratification. The other option apart from stratification is we can do a multivariable analysis. So we depending on what is our outcome variable, we can go with if it is a continuous variable, we can go with a linear regression. If it is a binary variable, we can go with a logistic regression and so forth. So with this, I conclude my presentation on bias and confounding. So these are aspects that we learned about bias, different types of what is bias, different types of bias. How do we address bias? What is confounding? What is a confounder? And how do we address confounding in studies? These are my references for the presentation. Thank you.
Thank you so much, ma'am.
I hope I concluded within time. Thank you so much.
Thank you so much for this wonderful presentation. Many of your doubts are actually cleared. Our participants will be taking one question from the chat box.
Yes, sir.
There is a question that are there any methods, whether tools or scales, to assess the selection and information bias? If we identify any bias in the published article, how should we evaluate the reliability of the findings? Two questions, two separate questions.
Yes, sir. Yes. So when we look at the selection, okay, we can look at we discussed that it could be addressed at different stages, right? So tools or scales to assess the selection and information bias, we have to focus on the methodological rigor of the study, basically. So all these things that we discussed about, these have to be incorporated at the design stage itself. So we have to look at whether the studies was designed appropriately or not. And coming to again, it's the same thing. We have to train the data collectors. We have to ensure the calibration of the equipments are right. And if we identify any bias in the published article, how should we evaluate the reliability of the findings? So again, so reliability and validity are two different things, right? So primarily our focus about bias is on validity. Then comes reliability. I hope I had it.
Oh, okay, I'm giving the mic to the one who asked the question.
No, actually, if we find any selection bias or any bias,
But you're not audible, sir.
is it audible now? One second.
Hello?
Hello. Is it audible now?
Yes, sir. Yes, sir.
Now, if we find or observe any bias in the article, published article, so how do we go ahead with the findings of that article? So we know that there is a selection bias in the article.
Right.
So how do we go ahead with that? We need to rely on the findings of that, or we should leave it aside, or how do we need to approach the results of that study?
Yes, sir. Sir, so if you most commonly what happens is any study will have some inherent biases to it, how much ever we try to minimize. So that is usually reported in the limitations of the study, and when we look at the findings of the study, again we have to keep that in mind, and then only we have to see. So sometimes where we have, like for example in systematic reviews we have risk of bias assessment itself. There are different tools that are available depending on the different studies, and those can be used to evaluate whether the findings of the study are reliable or valid.
Ma'am, one last question. Difference. There is a question from one of our participants. What is the difference between randomization and random allocation?
Okay. So randomization basically is the key concept in randomized control trial here. Random allocation is basically the way in which we allot it to the different groups. Okay, the way in which the sample is being allotted to the different groups. But in randomization it is more systematic. So it is we can follow different measures, and there are different types of randomization as well.
Okay. Thank you so much, ma'am. It was really a wonderful session. Thank you.
Thank you, sir. Bye.
Thank you so much, ma'am. AIIMS Rajkot extends its gratitude by presenting token of appreciation. So I request Dr. CME ma'am, Dean Examination, to present a memento on behalf of the Institute, and I also request Dr. Mehul sir to receive the memento on behalf of Dr. Vijay Gita.
Thank you so much.
Thank you, ma'am. So moving forward, I would like to invite our next speaker, Dr. Amit Kumar Mishra. Sir is an assistant professor in the Department of Community and Family Medicine, AIIMS Rajkot. Currently, he is conducting an ICMR-NI project on SARI funded by CDC Atlanta as principal investigator, and ICMR STERIC project for Indian reference intervals as co-PI. Sir has received various awards and has 40 publications in index national and international journals. Over to you, sir, Dr. Amit Kumar Mishra.
Good afternoon, everyone. Am I audible?
Yes, sir, you are audible.
Okay, thank you for the introduction. First of all, I would like to thank Dr. Agarwal sir, Dr. Joshi sir, and Dr. Padi, and the organizing team for giving me this opportunity to participate in this National CME on Research Methodology. I hope I'll do justice to the topic within the time allotted to me, because it is very difficult for me to present the topic which is allotted to me actually within the specified time period. Let me share my screen. Okay, is it visible to everyone?
Yes, sir, it's visible.
And I'm audible also.
Yes, sir.
Okay, thank you. So, without wasting time, let's start the topic because there are many slides on this topic. So, based on our experience and based on the ideas we have, we usually plan to conduct research. And when we plan to conduct research, we develop the protocol. And while developing the protocol and when we are preparing the research methodology, the methodology part of any protocol, that time we are realizing that we don't have ample fund and manpower to conduct the research, including all the participants. So now the next question which comes to our mind is, how many participants I have to include in my study so that the findings can be generalizable to the target or reference population? Again, if I am taking n number of study participants in my study, then how I am going to select this n number of participants out of the total target or reference population? So today we are going to discuss the answer to these two questions, and I'm going to discuss here the different sampling methods and the sample size calculation. Usually research is a cycle, and always in research we try to find out the answer to a research question, and when we get the findings or results and we extrapolate that one to a population, that will create or that leads to another research question. That's why it is a cycle. But it is not possible to include all the study population or target population in our study. So what we usually do is we just observe a small sample and we try to collect data from that small sample and we extrapolate that results or findings to the target or to the reference population. So why this small sample is required? Why not the total population or the target population we can include in our study? Because it is impossible to study the whole target or reference population. Again, if we do sampling perfectly or correctly, then even that small sample will represent the total whole population or the target population. So it will reduce not only the cost, but it will be very helpful for collection of data, because we are not going to collect data from a larger population but a small sample, and definitely it will reduce the time of our research also. So when we say the sample which we have selected is good, the sample will be good when the sample is representative of the target or reference population, when it is appropriately sized. Now what does it mean? Appropriately sized means the sample is larger enough so that whatever details or findings we get from the study can be generalized to a target or reference population. If we are just getting the information from just 5 or 10 participants, then definitely we are not going to generalize the findings to a larger population. The sample should be, when we do the sampling, it should be unbiased. In previous session we have seen that in all types of studies, when we do the sampling or data collection, there are so many types of bias which we encounter in research. So it is very difficult to avoid bias, but there are methods to reduce the chances of bias. And it should be random selection. When we select the participants from the target population or from the study population, it should be a random selection. It is better to have a probability sampling, which we are going to discuss in subsequent slides, than the non-probability sampling. So there are many advantages of this sampling when we take a small sample than the target population, because it will reduces the resources like men, money and materials, and also it will reduce the workload on the researcher. Again, if we do proper sampling, then the results with known accuracy will get, and we can extrapolate that results or findings to the target population. Again, there are always biases in any type of sampling. Sometimes it is very difficult to get the participants for our study sample. It is very difficult sometimes to select the participants for our studies. Though we get the participants for our study, it should be representative of the target or reference population. That is what is important in sampling. We have to remember the three principles of sampling. The first is we are not including the total target population or reference population in our study. We are just including a part of it. So because we are including a part of it, that there is always a difference between the sample statistics, the findings which we get from the sample, and the population mean or the population parameters. Again, the answer to this problem is the second principle, that is, greater the sample size, the more accurate the estimate of the true population mean. If we increase the sample size, that means we are moving towards the population parameter. Now, the greater the difference in the variable under study in a population, the greater the difference between the sample statistics and population parameter. For example, suppose in a study population, the age is distributed from 18 years to 80 years. Means there is a variability in the age in the study population. When we take a small sample, please note, small sample from the study population or from the target population, and when we calculate the mean in that sample, neither it will be exactly same as the population mean, nor it will be close to the population mean. That always there will be a difference. There may be a bigger difference between the sample statistics, sample mean, and the population mean, because the variable under study, the distribution of that variable in the study population is y. Okay, so we have to keep these three principles in our mind while planning for sampling in our research. So target population is also known as the reference population. So target or reference population is the population to which the investigator or the researcher wants to generalize his or her study findings. Now we don't have access to this target or reference population always. So what we do is we take a study population, which is the part of the target or reference population, and we have now the researcher or the investigator, they have access to this study population. Now, sometimes it is not possible even to list all the participants or individuals or the people who are in the study population, but based on our study setting, we can prepare a list of the possible participants for our study. That is known as the sampling frame. So sampling frame is maybe equal to the study population or maybe part of the study population from which we are going to select our study participants for our sample. So sample is the final small group of people or individual or patients from whom we are going to collect our data based on our objective. Bias, ma'am has already discussed in previous session regarding different types of bias in research, but related to sampling, the biases are categorized into two categories. So the first one is sampling bias, which is related to the sampling method, and the non-sampling bias, it is because of the participants' responses inside the sample. In the sample. So sampling bias is due to selecting a sample instead of the entire population. As I told, we are taking a small sample of the target or reference population, not exactly the target or reference population. And that's why there is always a difference between the sample statistics and population parameter. And that difference, that error is known as the sampling bias. It is because of the sampling. Now, for non-sampling bias related to the responses of the participant in the sample, it is again categorized into non-response bias and response bias. So I'm not going to discuss this one because ma'am has she has already discussed the non-response bias and response bias in the previous session. So the sampling methods are broadly divided into two categories based on the probability. Now, probability means when we have the study population and we have developed a sampling frame, and from the sampling frame we are selecting the study participants for our sample. Now, based on the probability of individual participants or individual units probability to get selected in the sample, the sampling methods are categorized into two categories: probability sampling and non-probability sampling. In probability sampling, each and every individual in the sampling frame, they have equal chances, equal probability to get selected in the sample. But in non-probability, this is not the case. So probability samplings are again of different types: simple random sampling, systematic sampling, stratified sampling, and cluster sampling. We'll discuss one by one in subsequent slides. So first let's discuss about probability sampling. As I told, probability sampling means the individuals or the units or the elements in the sampling frame, they have equal chances or probability to get selected in the sample. So that's why it is known as probability sampling. And among all the methods of probability sampling, the simple random sampling is the best method of probability sampling. Random sampling is the process of using chance or probability to select individuals from a population or from a sampling frame to be included in sample. Now, for probability sampling, we need a sampling frame. And how we are going to get the numbers to whom we will select from the sampling frame in our sample? For that, we have to use the random number table or the table of random numbers. We can use lottery methods if there are 10 people and we have to select 2. So we can put lots, 10 lots with 1, 2, 3, 4, or we can write the name also and we can fold the papers, and we can select any 2 out of that 10. So table of random numbers is the most commonly used method for to generate the sequences or to generate the numbers, random numbers for simple random sampling. Lottery method is another most common method used for this sampling method. Again, many researchers, they use the computer generated random numbers for random sampling, simple random sampling. But we have to remember that programs do not act randomly. They keep that sequences or numbers based on the programs, based on the details already inside this program. So it won't act randomly. So we have to keep that one also in our mind while generating the random numbers in a computer. So the advantages are this simple random sampling is very easy method to use. And as I told, this is the best probability sampling method because each and every individual in the sampling frame, they have equal chances to get selected in the sample. But there is a disadvantage. If the sampling frame is very large, this method is not possible because we will get haphazard numbers and we have to approach that particular population. We have to approach that individual. We have to approach to get selected in our sample. So in large populations, sometimes simple random sample is not applicable or not possible, though it is the best method of probability sampling. The next method of probability sampling is systematic sampling. For example, in a classroom there are 40 students and I need a sample of 10 students. So I have to calculate first the sampling interval, that is nothing but the total population divided by the sample size, that is 10. So 4 is the sampling interval here. Now what I have to do do is I have to select a random number between 1 to 4. Because I am selecting a random number between 1 to 4. So 1, 2, 3 and 4, all these digits, they have equal probability to get selected, and that's why it is known as the probability sampling. So once I have selected the digit, that is 4, now I have to add the sampling interval 4, and I have to check the sequences, the sequences or the rule numbers. For example, first I have selected 4. Now I am adding the sampling interval 4 with 4, then 8, then again plus 4, 12. So this is the roll number of the students who are included in my sample, 4, 8, 12, 20 and 24. Here one thing we have to know, that between 1 to 4, the probability is same for all the study participants, between 1 to 4. But once I selected 4, the probability of 5, 6 and 7 to get selected in my sample is 0, because the next number is 8 roll number. So that's why few researchers, they will say it is just a mixed method between the probability and non-probability sampling. The advantage is it is easy to select. The sample is evenly distributed in the entire target or reference population. It is more cost effective. The disadvantage is, as I told, all the individuals, they don't have the equal chances or probability to get selected in the sample. Next probability sampling is stratified sampling. Sometimes there are factors which can affect the outcome. One example is, if my objective is to find out the mean hemoglobin level in a population. Now we know that hemoglobin level in females is lower as compared to the male participants, male population. So if I include only male participants in my study, then definitely I am going to get a biased result. Or if I include all female participants in my study, then definitely it will get a biased result. So in that case, because I know sex is a factor which can affect my outcome, so I can divide the target or reference population, that population in that particular geographical area, into two groups. One is male and another one is female. Now from each group, that is from males, I can select few participants. Now from the females group also I can select some participants. I can use simple random sampling now in these groups to get my sample. Either I can take equal number of males and equal number of females, but if at the same time, if my objective is to find out the mean hemoglobin level in that particular geographical area, in that case I have to learn about the composition of that particular population with respect to sex. If the population of males are twice the population of females, in that case I have to include the participants in my sample in the same ratio. So if the sample size is 60, I'll include 40 males in my study and I'll select 20 females in my study. So we have to maintain the proportion if our objective is to find out the mean hemoglobin level in that particular area. So that one also we have to keep in our mind. So stratified sampling is a better representative of the target or reference population. It has higher statistical efficiency. It is very easy to carry out. But at the same time, classification error or classification into different groups, into different strata can be a problem. So because we need some prior information, and for example, if you want to divide any population based on smoking, then it is very easy to divide whether they are smoker or non-smoker. But if we have to divide the population based on the number of cigarettes they are smoking per day, then there will be a problem. Again, it is a time consuming and more expensive, and we need information related to the composition and distribution of the population in the target population or in reference population. Then only we can make different strata or different groups for sampling. Another probability sampling is cluster sampling. When the target population or the reference population is in a greater geographical area, sometimes it is also known as area sampling. Usually what we do is we take cluster sampling. What is cluster? Cluster is a collection or group of individuals, and here the target population or the reference population are divided into different clusters. And from each cluster, now we select our sample. First we select randomly few clusters, and then from each cluster we select the sample, means the participants for our study. Now it raises two questions. How many clusters do I sample? How many individuals should be in each cluster? Because we are selecting first randomly the clusters and then selecting participants from each clusters. So how many clusters we have to include? How many participants we have to select from each cluster? So the answer to this question is we have to first find out the whether the clusters are homogeneous or heterogeneous. If the clusters are homogeneous, in that case there are chances of duplication of information from the participants. In that case, we have to include more number of clusters with fewer individuals in each cluster. So that will get we will include more number of participants from many different clusters. If the clusters are heterogeneous, that means it resembles the total or the target or the reference population. That means it is representing the target or reference population. In that case, we can take fewer clusters with more individuals in each cluster. It is same as simple random sampling. In simple random sampling, we are just taking one cluster, assuming that the cluster is totally heterogeneous, and we all are taking individuals from that single cluster, that is in simple random sampling, assuming that the individuals in simple random sampling in that particular population is heterogeneous. Here one thing I want to emphasize is when we calculate sample size, the sample size for cluster sampling is less as compared to simple random sampling. But there are chances of duplication of information when we collect details or information related to our objective, and that's why to solve that particular issue, to duplication of the results or findings, we consider the design effect in cluster sampling, so that when we multiply with the design effect and we take a larger sample, it is close to the simple random sampling. Again, how we have to take the participants from each cluster. Based on that one, the cluster sampling are of different types. So if we are taking all the participants in the cluster, then it is single stage cluster. If we are preparing this sampling frame in the clusters, and then we are using simple random sampling in the cluster, then again there are two steps. First step is the simple random selection of the clusters, and now again simple random selection of the participants in each cluster. So there are two stages. So it is two-stage cluster sampling, and sometimes we have to use the stratified sampling in each cluster. In that case, it is known as multi-stage cluster sampling, where in each cluster we can use the stratified sampling method to select our study participants for our sample. So another probability sampling is multi-stage sampling. It is nothing but a type of cluster sampling where we are following different stages. For example, if I am planning to conduct a study among adolescents in slum areas, then it is impossible for me to develop a sampling frame of all the adolescents present in all the slums in Rajkot city. So what I have done is, the city has been divided into different zones, and zones have different 7 numbers of words, and from each word there are different slums. So what we did is we selected one zone in the city out of the total 10 zones, and in the selected zone out of the 7 words we selected just one word, and out of the total number of slums present in that particular word, we prepared the sampling frame of the number of slums in that particular word, and we selected one slum randomly. So in each state we are using the random sampling again. And finally the slum we selected, and then we prepared the sampling frame of adolescents in that particular slum, and then we recruited the study participants based on our sample size. So this is multi-stage sampling. Another sampling method is multi-phase sampling. Here already there is a sample. For example, the TB cases. All the TB cases I have included in my study. They are the sample. Now I have another objective where I am interested to include TB patients having diabetes who are on treatment and having retinopathy as a complication of diabetes. So for data collection, no need to include all the TB patients in a particular sample. So what I have done is, in the first page, I collected data related to their diabetes status, and those who are positive for diabetes, I took them to the second page, and I collected data regarding whether they are on medication or they are not on medication. Then those who are on medication, I took them to the third page, and I asked about the complications of diabetic retinopathy. So those having diabetic retinopathy, finally they were included in my sample. So this is known as multiphasic or multi-phase sampling, because we are doing the sampling in multiple phases. Usually this type of sampling is done when we have limited resources, we have limited manpower, we have limited budget, because it is not possible to ask or take interview of all the study participants at different phases, or test the lab investigations to perform in all the phases. So only who are positive in a particular phase can move to the next phase, and that's why it is known as multi-phase sampling. So all these are probability samplings. Let's now discuss something related to non-probability sampling. So non-probability sampling, as I told, nothing is related to the probability, because it is non-probability sampling, and the researcher or the investigators, they are including the study participants based on their own convenience. The first type of sampling, non-probability sampling, is convenience sampling. Here, the researcher or the investigator, they try to include the study participants in their research based on their own convenience. For example, if we don't have time or manpower or budget to go to the field to collect data, we can share the questionnaire in email or WhatsApp, and we can get the responses. So that is based on our convenience. We are doing that one. We are getting the responses. But the problem is, it is not representative of the target or reference population, because we don't know who all have replied to our questions or emails. So that is convenience sampling. So it is easy to apply. It is immediately known population. We can apply to them, and we can expect a good response rate. Only those individuals we can include in our study or in our sample for data collection. But the problem is, we cannot generalize the study findings to the target or reference population, because it is not representative of the target or reference population. The second non-probability sampling is purposive or judgmental sampling. Here, purposely we are including only those study participants who are going to give us good response. For example, if there is a disease, and unless is known about that particular disease, and you are the investigator and you're just trying to collect more and more information related to that particular disease, then we try to include only those participants who will give or will respond to our questions, and who are going to give all the information which we want as per our objective. So there is a control over who is to be included in the sample by the researcher or investigator, but the same problem, it is not representative of the target or reference population. So that is the problem in non-probability sampling, the generalizability. We cannot generalize the findings or results to the target or reference population. Another one is quota sampling. Here, the researcher or investigator can divide the total population into different subgroups which are mutually exclusive, and then they will fix some quota with some specific characteristics. For example, I can divide the population into two groups, males and females. Then I can fix, I just want 70 males in my study and 30 females in my study with a characteristics of age more than 40 years. So the researcher or investigator, they just decide the quota and a particular characteristics to include the study participants in the research in the sample. So it is usually done for public opinion studies, and it has many biases because the researcher or investigators, they are taking the whole decisions regarding whom to include, whom not to include. So there are many biases in this kind of sampling. Snowball sampling, sometimes it is not possible to get the sample size or to achieve the sample size because one example is the participant with sexually transmitted diseases. So it is very difficult to get such type of patients or participants in studies. Even they are available in the hospitals, in OPDs and all, but sometimes they don't give consent to participate in the research. In this kind of scenario, we can ask the study participants to search and bring related study participants to get included in the study. It is simply like the propagative epidemic in epidemiology. So the one participant which we select, they have the contact details of many more sexually transmitted disease patients, and they will bring. So it will continue till we achieve our sample size. So that is known as snowball sampling. And another example is the intravenous drug users. So it is very difficult to get such type of participants for study. But once we include or get one participant, we can ask them to bring many more participants for the study. So they have the contact, so they can bring such type of patients or participants or individuals for the study. So probability samplings, in probability sampling, the sampling frame is required and the skills of the investigator or the researcher is required in probability sampling. It is more time consuming, more expensive, but it is a good representative of the target or reference population. The findings or the results are more accurate and reliable, and when we extrapolate the findings to the target or reference population, we can do it unbiased, without any bias. But in non-probability sampling, you can see it is less expensive, doubtful, and we don't know regarding the accuracy and reliability of the findings which we get from that kind of sampling, and it is full of bias. Now we have already discussed about the sampling. Now we have the idea how to select the study participants for our research, but how many? So that is another question related to research methodology. When we develop research methodology and we write the study design, the study setting, at the same time we are more interested to know how many study participants we have to include in our study so that the findings can be generalizable. We can generalize the findings to the target or reference population. At the same time, there are many other barriers or constraints. One is the budget, one is the manpower. If we increase the number of participants in the study. So sample size is the number of individuals in a group under study. It is the subset of the target or reference population. In census, the sample size is equal to the population size. There are information which is required to calculate the sample size. what type of study design means the epidemiological method, what type of study, whether we are taking one sample or we are comparing between two samples, what is the outcome, whether the outcome is a mean or the outcome is a proportion, what is the expected variability between the subjects, and we have to also think about the margin. That means how large a difference would be considered clinically important and reasonable. That means in clinical trials and all, we also have to decide a specific margin to decide whether the intervention is better or it is superior or inferior or equivalent to the placebo or standard care. So sample size for any study depends on the level of significance, the power of the study, expected effect size, that is the difference between the two groups, the underlying event rate in the population. For example, in agreement studies, when we calculate the sample size, it also depends on the prevalence of that particular disease, event or condition in the population, and the standard deviation of the population. So these are the parameters on which the sample size depends on. Let's discuss few formally and in different epidemiological methods. So the most common type of epidemiological studies are the cross-sectional studies. So if in any cross-sectional study, if the outcome variable is a categorical variable, means we are just want to measure the proportion, then this is the formula where we have to consider the normal variant for level of significance, the Z alpha, that is at 95% level of significance, the value is 1.96. P is the prevalence, which we get it from literature search or from our own experience and all. And D is the precision. It may be absolute or it may be relative. Actually, if the P is 40% or 50% or 60%, in that case we take absolute precision. But if the prevalence is very, very low, like 1%, 2% or 3%, in that case we take relative precision. In any cross-sectional study, if the outcome variable is a quantitative variable where we just want to find out the mean, for example hemoglobin or the blood pressure, where we are interested to find out the mean, this is the formula where we need the standard deviation from a previous study, and again the D is the absolute error or the precision. In case control study, where we are taking two groups, one is cases and another one is controls based on our operational definitions, and we just want to compare the proportions of exposure in cases and controls in our study, then this is the formula for sample size calculation, where R is the ratio of control to cases. Normally we take 1:1, but in few studies we can take 2 or 2:1 or 3:1 also, that is control to cases. So accordingly we have to take the value of R, where P is the average of P1 and P2. P1 and P2 are the exposure rates in cases and controls. Here we have to consider the power of the study also, that is the Z beta, which we have to put for 80% the value is 0.84, and for 90% power it is 1.282. So this is for comparison of proportion in cases and controls. Sometimes we also compare the mean, the exposure we present in terms of mean between the cases and controls. In that case, if that is our objective, so this is how we can calculate the sample size, where R is the same ratio between ratio of control to cases, and ST is the pooled standard deviation. Here we are considering both the Z alpha and Z beta, that is level of significance and power of the study. Usually for power of study, the minimum we take is 80%, that is 0.84. The Z beta value is 0.84. For cohort studies, where we are interested to find out the incidence of the disease in the exposed and unexposed group, that is P1 and P2, and we just want to calculate the relative risk, that is we just want to measure the risk associated with the exposure. This is the formula we can calculate the sample size. For clinical trials, there are three different types of clinical trials. One is superiority trials, non-inferiority trials and equivalence trials. There are slightly different formulas for these different types of trials. So this is a formula for superiority trial if the outcome variable is a quantitative data. That means we just want to measure the mean in the exposed group and in the unexposed group. In that case, this is the formula. Here we have to note that the delta is the superiority limit or the superiority margin we have to fix. It should be fixed by the researcher or the investigator when we can say that the intervention is superior to the placebo or to the standard care. So we have to fix that margin. It may be 1%, 2%, 10%, but it should be decided by the researcher or investigators based either on the literature or based on the clinical experience. If the outcome variable is qualitative, in that case, this is the formula for clinical trials, for superiority trials. The formulas are different for superiority trial, inferiority trial, non-inferiority trial, and equivalence trial. Slight difference, but here also we have to fix the superiority limit. Here we are measuring the outcome variable in percentages. For example, if we are testing a vaccine, and we are just wanted to find out what is the proportion of participants who are developing the disease at the end of 2 years. So in the placebo or in standard preventive care, it is 40%, and in the vaccination arm, it is just 30%. So there is 10% reduction in one study. So whether that 10% is clinically significant or not, we have to decide, and we have to fix the superiority margin for sample size calculation. So in all these calculations, in all these formulae, I told about data is required about P, standard deviation, then the superiority margin or the mean. So this P value, ST value, or the mu value, from where we will get these values to put in our sample size calculation. So there are 3 methods to get all this data. The first one is from literature search. We have to search the literature, and if there are similar studies are conducted, then we can take the data from that similar studies to calculate the sample size. The second one is by pilot study. If you are doing a new kind of study, it was not done previously, then you can do a small pilot study, and based on the pilot study you can calculate the sample size. Even if it is not possible to conduct a pilot study because we need budget and manpower also for the pilot study also, in that case we can calculate the sample size based on our experience. So either from the literature or from the pilot study or from clinical experience or based on our own experience. So there are different softwares which are available in the market. Few are freely available, few are paid to calculate the sample sizes. But the most, for last many years, the software which I am using for sample size calculation is the N-Master version 2. This software is developed by the Biostatistics Resource and Training Center by CMC Fellow. This is very user friendly. You can see the interface, and it is very easy to use for sample size calculations. It is based on the outcome variable and the epidemiological method. So if you have any doubt regarding sample size calculation, what to put, where to put, then there is another option, another tool called help. So you can click this help button and you can get all the information related to the fields which you have to fill to calculate the sample size. Here you can see that there are examples are also there for sample size calculations. So it will help you to calculate the sample size. And this is how I have calculated the sample size for a cross-sectional study where my objective is to find out the proportion of people having that particular condition. So here I have just included at 0.4, that is 40%. I got this one from literature that in a study it was reported that that particular disease is 40% prevalent. So I took that 40% as 0.4. With the precision of 5%, I calculated the sample size as 369. So another advantage of this software is you can calculate multiple times in the same window, and you can check which is feasible for your particular study. So this software is not free actually. When I bought this one, it was around 2,500 with taxes and all. So if you want this software, then you can contact the Department of Biostatistics, CMC Value. So I hope I have made justice to the topic allocated to me, and whatever we have discussed now, I think it will help you in preparing your protocol or in conducting your research in your respective places. Thank you.
Just a minute.
Hope I have completed within time.
Yes, sir. 5 minutes before time. Thank you so much. We'll be taking few questions from the chat box. There is one question. If convenience sampling is done for a population, how to write this in the manuscript? And the second one is there any criteria to decide if convenience sampling is okay to be done in a study?
Can you repeat the second part of the question?
Second part is there any criteria to decide if convenience sampling is okay to be done in a study?
Actually, related to the first one, how you... Yes.
No, sir.
Am I audible?
Yeah. Yes, sir, you are audible.
Yes. Related to the first part of the question regarding how to present it in the manuscript, if you have done convenience sampling, then you have to explain in your methodology part that you have done convenience sampling, because the findings which you have got from your study, it cannot be generalizable to the target or reference population. So you have to mention in your manuscript that you have done convenience sampling. And second part, there is no such criteria that convenience sampling is better than simple random sampling. Convenience sampling we usually do based on our own convenience. If there are 10 students and you have to select only 2, then you try to call those 2 students who are known to you. So that is how usually we do for convenience sampling, because you know that 2 students, and you because that 2 students will give you the answers which you want to, the questions you want to ask. So that's why you have selected that 2 students. So convenience sampling is based on the convenience of the researcher. So you have to mention it in the manuscript. There is no such criteria for convenience sampling.
Okay, sir. Sir, one more question. What is the ideal percentage, 10% or any, of the calculated sample size to account for attrition bias in clinical trials? Additionally, does this percentage need to be adjusted in relation to the duration of follow-up?
Okay, actually that is equivalent to the non-response rate. Actually, in normal research, when we calculate the sample size, we take a non-response rate of 10%. So you have to keep, if you are expecting based on your objective or whatever, or based on the questions you are going to ask, or based on the data you are going to collect, if you are thinking that there are chances that you won't get the answer, or you won't get the laboratory findings for that particular participants, you have to keep it in the mind while developing the protocol. Okay, so if you are considering 10% as the non-response rate, and finally 20% of the participants they are not responded to you, then the sample size you have calculated is not correct. So you have to keep in mind, normally when we calculate sample size, we take it 10%. But sometimes you can take 20% also. But when you are developing a protocol and you are preparing a budget, you cannot take just roughly 20% or 30%, because the budget depends on your sample size. If you take 20% of non-response rate, that means your sample size is very high. That will increase your budget, and there are less chances that your protocol will be get selected for the funding. one thing you can do is there are different methods to reduce the chances of attrition. You can follow that one. If you have considered only 10% as non-response rate, and when you have started the study at that time, you have to include only those participants. Maybe you are doing random sampling or systematic sampling, whatever method you are using. You have to include only those participants who are going to stay in your study till you are going to follow them up. You try to include those participants only. If you just blindly, if you include all the study participants, then definitely the non-response rate will be very high.
Thank you, sir. Thank you so much for your wonderful presentation. You can also go through the chat box. Your session has been very well appreciated by our participants across India and from.
Thank you all.
Thank you, sir. Okay, go ahead.
May I now request Professor Dr. Colonel Ashwini Agarwal sir to present a memento on behalf of the institute. I also request Dr. Abhishek Padi sir to receive it on behalf of Dr. Amit Kumar Mishra.
Thank you, sir. Thank you very much, sir.
On moving forward, I would like to invite our next speaker, Dr. Pradeep Agarwal. Sir is an additional professor in the Department of Community and Family Medicine, AIIMS Rishikesh. He is a fellow of Indian Association of Preventive and Social Medicine and International Medicine Science Academy and Royal Society for Public Health London. Sir holds early career epidemiologist Southeast Asia region of International Epidemiological Association, and Sir has more than 150 publications. His area of interest are public health informatics, data management and research methodology. Over to you, sir, Dr. Pradeep Agarwal.
Yeah, hello. Just I'm opening my slides. Very good afternoon. Can you see my slides, sir?
Yes, sir.
Yes, sir. Yes, sir.
Okay. Very good afternoon to everyone, and I hope we are running on time. Can I make my presentation both in English and Hindi? And I hope the audience are a mixed group, more focused with the postgraduate and undergraduate students. If I am correct, somebody can put in the post chat yes or no, so that at least I am aware that you people are responding.
Yes, sir.
Topic from the organizers. Can I go ahead?
Yes, sir.
Okay. So the topic allotted to me is the ethical aspects and ethical aspects of the healthcare in the research. Now, coming, can you hide this screen, ma'am? ऊपर का बार-बार वो remote आ जाता है. Okay. Yes, hide this. Just hold on.
Minimize the screen sharing. AIIMS are good.
Yeah, right. तो यहाँ हमारी जो बात हो रही है, अभी हमने देखा, कल भी हमने सुना था डॉक्टर उमेश कपिल को, डॉक्टर अनिमेश जैन को, आज भी हमने बहुत सारे रिसर्चर्स को सुना. हमारे रिसर्च में जो सबसे बड़ा एक इम्पॉर्टेंट कंपोनेंट है वो है एथिक्स का. The thing which we are doing is whether it is an ethical or not. And as a research, we have a very big phobia in our mind by the word ethical. Ethical committee will be there. They are going to review my document. They are going to ask lot many things. They are going to ask regarding the questionnaire. But during the course of next 20 minutes, I will tell you what is ethics. And a researcher should never feel afraid of the word ethical. It is a safeguard for you. Please understand that it is a safeguard of you. That is the main objective of my taking this presentation to you all. So, in a health research fundamental, ethical considerations are of paramount in a health research. Any research involving human participants must adhere to the ethical consideration that is internationally acceptable. Even if in a situation there is a minimal risk, we should have an ethical review. Even if you are collecting a data, if you are going for a survey, please get your research, please get your thesis, please get your dissertation reviewed from the ethics committee. Please get an ethical approval before you proceed with any kind of a research. Now, during the course of this presentation, I will be taking a few important things. What is the goal of ethics? What are the national and international guidelines? What currently we are practicing? What are the principles of ethical studies? What are the risk and the benefit assessment? And the key important component of today's presentation in ethics is the consent. क्या आपके पास मरीज की या आपके जिससे डाटा ले रहे हैं उसकी रजामंदी आपके पास है कि ये पेशेंट की इंफॉर्मेशन आप रिसर्च पर्पस के लिए यूज कर रहे हो? This is a consent, and consent need to be a confidential, explanatory, and at any given point of time, an individual can withdraw in between within the research. So that is what we are going to talk of the consent. Every institution, we are sitting in INI, Institute of National Importance, AIIMS. We abide to the maximum robust ethical committee's review. And that is coming from the Institutional Ethical Committee, and somewhere it is being known as Institutional Review Board also. So that can be also there. And internationally, these days there are not many organizations, NGOs and agencies which provide you a certificate of good clinical practices. As a researcher, we always say that we should have a certificate of good clinical practice. In that online course, you can get all of the details. If I am clear, can I move ahead? Can the organizer tell me? Can I move ahead?
Yes, sir.
Okay. Now coming to the goal. If I come to the goal, then the goal says basically we have to develop generalizable knowledge to improve health. This should be the goal of a research which we are doing on the human participant. To understand and increase knowledge about the disease. And ethically, it should be justified by the social values. This is the main reason why we are doing research on human participants. So these are the international ethical guidelines. If we see, it started at the time of independence by Nuremberg Court. Helsinki is in Finland, 1964. Then comes the Belmont Report in 78. And then comes the CIOMS guidelines in 92-93. I am not going to detail, but what I want to show you over here, from last 75 years, the things are in process. Nationally, internationally, guidelines are being developed. These are ethical guidelines. And these considerations are taken at an international level. I will focus more on what we are practicing in India. The Apex Research Institute of India, that is Indian Council of Medical Research, in 2017 have came up with the national guidelines that are available freely on ICMR website, and it says National Ethical Guidelines for Biomedical and Health Research involving human participants. Along with these, there are other relevant guidelines also, but I am not going into those details. Let's focus on what is available by the ICMR in the form of ethical guidelines. I request everybody please scroll the link or go to the website and you can download it free of cost. Just review this document. That is a key important document for every researcher. Every institutional ethics committee should provide a copy in an email to their faculty, to the postgraduate students. Ethics के principle क्या है? हमें करनी है तो कुछ ना कुछ तो प्रिंसिपल्स होंगे. सबसे पहले है ऑटोनॉमी. We have to respect individuals' decisions about their lives, in ensuring informed consent, empowering them to make choice. आप किसी पे भी काम कर रहे हैं, उसके ऊपर छोड़ दो क्या वो आपके साथ रिसर्च करना चाहता है, नहीं करना चाहता. क्या वो आपका पार्टिसिपेंट बनना चाहता है, नहीं बनना चाहता. अगर वो बीच में भी कभी भी आपके during the research voluntarily withdraw करना चाहता है, that choice should be with your participant. So first is autonomy, second is justice, treating all individuals equally and fairly, ensuring equitable access to the research opportunities, and avoiding imposing unfair burdens. So whether you are taking any rich or any who is not from a low social class, you have to ensure equal treating opportunities are given to all your participants. Beneficencies, acting in the best interest of the research participant, maximizing potential benefit and minimizing harm. I am repeating the word minimizing harm. आप प्लीज अपने रिसर्च के रिजल्ट के लिए कोई भी ऐसा काम नहीं करेंगे जिससे कि आपके पार्टिसिपेंट को नुकसान पहुंचे। मरीज का, उसके रिश्तेदार का, आपके पार्टिसिपेंट का रिसर्च में कोई बेनिफिट हो रहा है, दैट इज व्हाट शुड बी योर एथिकल प्रिंसिपल। नॉन मैलिफेंसी, अवॉइडिंग हार्म टू द रिसर्च पार्टिसिपेंट, adhering to the principles of first, do no harm, and maximizing the potentials and minimizing the potential risk. You are not going to do any research in which even a 0.00% there is a harm to a patient. It means you are not abiding to the ethical principles. So I am just repeating again: autonomy, justice, beneficencies, and non-maleficence. These are the 4 cardinal ethical principles of any researcher. Now, who is the one who is going to assess whether it is going to be a benefit or a risk? In this, there comes the role of your ethics committee. Ethics committee is going to assess your research beforehand and is going to understand whether your research is having a benefit or risk. So please try to put each and every research protocol through your ethics committee. What are the responsibilities of ethics committee? Evaluate the balance between the benefit and risk. Review plan for minimizing risk and discomfort to the participant. Reassess risk during continuing review process and address any change. With every ethical approval, you will see they are going to write in every 6 months, a researcher should ensure submitting a brief report of the work done in last 6 months, so that they have a track record regarding the risk which is being exposed to the participants. So please do submit every 6 monthly ethical committee your review report of the ongoing research projects. This is the important, the most important, informed consent. क्या आपने मुझसे पूछा आप मुझ पर रिसर्च कर रहे हो? आपने मुझे जानकारी दी कि आप मुझ पर रिसर्च कर रहे हो? So it becomes the responsibility of a researcher to take informed consent before proceeding for the research. So it is an ethical principle fundamental to the research, that is informed consent. Provide potential participants with comprehensive details. Procedure, risk, benefits, alternatives, confidentiality, compensation and contact information. But इसमें आपको सबसे ज़्यादा जो याद रखना है, your consent should be in a local language which can be understood by your participant. You have to give the opportunity to your participant if they have got any questions, any queries. Might be on the day of your research, your participant is not ready to give a consent. Later on comes back to you. Okay, now I agree and I am giving hereby my consent to be one of the participants of your research. So you have to ensure you have to give them a choice of making a voluntary decision to participate or decline after providing informed consent. I hope each and everybody is going to ensure taking an informed consent before taking any kind of or recruiting any participant in their research study. Okay, this is the same thing again. I'm not going to that detail. What are the benefits of informed consent? Informed consent benefits both research participant and investigator. In fact, it is a safeguard for you. If you have taken an informed consent, you are on a safer side. It empowers the participant to make an informed decision about their involvement in the research, ensuring their rights and welfare are protected. Moreover, for the investigator, it fosters trust, transparency, and ethical research practice. So please be sure you take informed consent with each and every participant whatsoever you are enrolling in your research study. अब आती है बात, जब आपने अपना लिखा प्रपोजल, जब ये प्रपोजल लिखते हो, this proposal goes for a scientific review in your ethics committee. And what exactly ethics committee looks at? So these are the key. Scientific review is essential for ensuring the quality, rigor and ethical soundness of the research. It involves thorough evaluation of the research proposal, including scientific novelty, whether we are repeating the same study, might be you are doing it on the different group of participants, so that becomes another novelty. You have to rationalize your study, whether it is really relevant in the current context that need to be ensured, and whether the objectives set to you are doable and your study is feasible or not feasible. So these are the components that goes while your scientific research proposal goes for ethical review. In the review process, assess the study design, inclusion-exclusion criteria, sample size, randomization procedure, endpoint assessment for option. If you ensure putting these things in your protocol writing, no ethics committee is going to turn down your research. They might provide you some kind of scientific evidence or documentation so that you can add upon your research and make it more robust. So please don't be afraid of ethics committee, but try to involve all these words which are given over here before you submit for scientific review. Now, the day when your research proposal goes to the ethics committee, ethics committee asks you bombard question to take you with the presentation. But if you see, the basic responsibility of ethical committee is to protect the dignity, rights and the well-being of the potential research participant. Ethics committee looks from a lens in which your participant is going to be exposed. To ensure the universal ethical values and international scientific standards are expressed in terms of local community values and custom. So if you are doing anything on a suppose breastfeeding practices, you have to understand what are the common community values and the customs in the local area in which you plan to do such kind of studies. So that is what they are going to ensure. So to assist in development and the education of a research community responsive to the local healthcare requirement. So your research should be in line with the local, national or the state goals that are required in that particular geographical area. So these are the basic responsibilities of ethics committee. The submission of your goes into the three categories basically. First is it can be directly exempted from the review, which is very less or minimal risk. That is a research for an educational purpose. So while writing your thesis, you have to justify your research is whether for just educational purpose. Expedited review. हमने कोविड वैक्सीन के टाइम पर देखा कि वैक्सीन को हमें लेकर आना था, then we have started with the expedited review. And another is the full review. That is a minimal risk that involves vulnerable population and the group by all the members. Then we have to go with the full review or the full board need to take up. This seems to be my, I hope, the last slide. Please search the word good clinical practices and you will get lot many online courses on good clinical practices. There are courses of 4 hours or 6 hours. Every postgraduate should have a certificate of good clinical practice and a biomedical research provided by the NIE. Both are online available, free of cost. These certificates should be made mandatory by the normal institution level. As a researcher, as an academician, everyone should have a good clinical practices. Why I am saying, once you apply for a bigger project, multi-centric project, ICMR project, they will by default ask for such certificate, whether you have undergone a training and a certification of good clinical practice. So I am not going to that detail, good clinical practice. My take-home message is respect the rights, dignity and the well-being of a participant. I know you are a good researcher, you are a doctor, you want to do something very good for the humanity, but at the same time you have to respect the right, dignity and the well-being of the participant. Ensure that the clinical research is conducted ethically with a focus on patient safety and compliance with the regulatory standards. You have to ensure there should be no risk, no harm to the patient. Proper documentation is a key success of any research. Please ensure you maintain a proper documentation so that it is crucial for transparency, accountability and reproducibility in the research. I don't want to name over here, but in the recent past we have seen articles that have been retracted from journals like Lancet, saying there was a lack of proper documentation. So documentation is going to safeguard your research, yourself from landing up into any kind of legal issues post-publication. I hope that is all from my end. Yeah, this is a small report. Thank you all to the healthcare researchers. If the research and the clinical practice are conducted ethically and documented with integrity, then transparency becomes your greatest defense and no one can harm you. So I am giving you all the weapons to conduct your research in which these are the ethical guidelines that need to be taken care. If you ensure these things, I can assure you one thing, your research is going to be 100% taken care of by the ethics committee in a review process. Moreover, their comments, contributions and inputs are going to help you out, making your research more robust, more acceptable, better publication after your research. With this, I hand over the mic back to the organizers. I hope I haven't shooted the time. Okay, I am 5 minutes ahead. It's open for questions. You can put it in the chat box. And if you want, I can just send you a good clinical practice course also that you can go for. GC.
Good afternoon, sir. Very nice presentation. Am I audible, sir?
Yes, sir. Please go ahead.
Sir, one question. As you mentioned about the documentation, for how many years we need to maintain the documentation of the clinical trials or the research? Like, for informed consent?
Currently, at least 3 years is the minimum time, but your regulatory bodies, ICMR or any other, might even take it for 5 years. But it is always advisable that you keep them, once you have the funds in your hand, please take a safe house or some kind of a safe in which you can put your documentation till the time it is required, and later on you can put it back to the funding agency, whosoever has supported your research. So your research committee in fact should right now think of, AIIMS Rajkot should right now think of if they can build up a repository kind of a documentation so that it becomes easy for the institution faculty to store those documentation and data. And standard policy can be set up like 3 years or 5 years as per your local requirement.
Thank you.
Thank you, sir. May I now request Dr. Deepak Pashwani sir to present a moment on behalf of the institute. And I request Dr. Krupal Joshi to receive it on behalf of Dr. Pradeep.
Thank you very much. Thank you. A wonderful team over there, and we all should inculcate ethics, day one any MBBS student enters into the institution. Thank you very much.
Thank you, sir. Thank you so much. So, moving forward, I would like to invite our next speaker, Dr. Yogesh Bahurupi. Sir is an additional professor in the Department of Community and Family Medicine, AIIMS, Nagpur. He is a member of the International Immunization Policy Task Force of the World Federation of Public Health Associations, Geneva, Switzerland. He is a National Assessor for Assessment on Effective Vaccine Management for Maharashtra, Assam, Madhya Pradesh and Uttar Pradesh. Sir has received total of 8 awards, has 4 book chapters and has many research publications in PubMed and Scopus. Over to you, sir, Dr. Yogesh Bahurupi.
Are the slides visible?
Yes, sir.
Okay. And I am audible to, I guess.
Yes, sir.
So thank you very much for providing me an opportunity to interact with you all. I'll be dwelling upon a topic which is a little bit crucial, but the entire process of research finally culminates with this statistical analysis. So throughout this session, I'll be going to discuss certain things regarding statistical analysis with you, which starts with why do we need to analyze, what are our prerequisites for our data analysis, what is descriptive data analysis, inferential data analysis. I'm going to take you to certain basic statistical tests, how do we decide upon them, and some of the open access software. But I'm just going to list out the software because of paucity of time. We won't be going to go into details of the software. So to begin with, why do we analyze data? The very reason we analyze data is to come to certain meaningful conclusions from the set of observations. So just imagine you have collected data about 10,000 or 500 individuals. Now if I have to just present this 100 individual data, I need to come to a particular number. A number which would have some meaningful interpretations so that this 100 individuals data can be used for certain decision making. So that is one purpose of doing the data analysis. The purpose we do data analysis is basically for reporting our findings. So that's basically for presentation in the scientific conferences or publication of paper. And finally, we analyze our data for testing of our hypothesis. So basically we have some presumptions and we want to show whether our presumptions are correct or they are wrong. So we analyze the data. So when we actually get into our journey, we need to first know how are we going to analyze data, what are the prerequisites for going for a data analysis. So first and foremost, lot of time people directly jump to the master chart and analyze the data. But I would definitely suggest you to first have a look at the protocol. Just go through the protocol, check the objectives and the expected outcome. The objectives are very important because they are going to give a guidance to you. How are you going to, for example, if suppose you have calculated or collected some data which is numerical one, but your objective suggests that you have to convert your objective into some risk ratio or some score like odds ratio. It means you have to now categorize your numerical data into categorical one and then calculate the odds ratio. So that is why you need to know your objectives very thoroughly, how those objectives would be quantified when it comes to your data analysis. Similarly, also have a look at the inclusion-exclusion procedure. Sometimes the raw master chart by default may have the data of participants who are supposed to be excluded and they are still part of the master chart. So it is always better to check the inclusion and exclusion procedure for data analysis. Next part is have a look at the data collection tool, the common parlance questionnaire. See how the data is being collected, how the data is being asked from the participant. Like a lot of people ask, we'll take an example of a variable like age. A lot of people will ask age in completed years. Some of them would be asking age in completed months. Some may be asking the age directly into the age categories like 5 to 10 years, 10 to 15 years, 15 to 20 years. So we need to know what kind of variable we have in our master chart. Now the same with age can be a quantitative variable, can be a qualitative variable, can be even a continuous variable, can be a discrete variable. So that is the reason I am requesting you all to have a look at the data collection tool, how the data is collected, and then see the data analysis plan from the protocol. So this is the protocol is like a guiding document. This is going to guide us how are we going to analyze our data, what are our expected, and now those expected outcomes are quantified. Next is, so this is how we basically starts analyzing the data. But before we start analyzing the data, we have to make a master chart. Now these are some of the points which I have noted down from my experience. There are certain do's and certain don'ts of making a master chart. So first and foremost thing would be always enter the data in similar manner, because lot of software is difficult for you to code the data later on. Like I gave an example, there is a variable called gender, and one of the response of that variable is male or female. So male can be entered in so different ways in same master chart, like in uppercase, maybe in sentence case, maybe in lowercase, maybe just an alphabet in upper and lower case. So when we would be coding the data for data analysis, it becomes a tedious process for us. So always make an attempt that when we prepare a master chart, it should be uniform. Next is make a proper variable names so that the names are unique, unambiguous, and it should not be duplicate one. So it should be very clear. The name of the variable should be very clear. It should give us an idea what information we are processing. Should be short, because there are certain software which do not accept variable names beyond 25 characters. So that is why we need to have a very short, clear name of the variable. Try to keep it consistent throughout the master chart. So when I say consistent, it means when you name a variable, try to name the variable in a sentence case. Like gender, the previous example which I gave you, I'll name this variable as gender, so G in uppercase and E and E here in lowercase. Why this is important? When I'll be analyzing the data, the same variable I have to change it every time the gender variable is used in data analysis when I'll be writing the result. So again, my task or my work will be increasing. So it is better to make proper variable. Then always check the type of variable, whether we are making a text variable or numerical variable. If it's a text variable, follow a particular pattern, like I have said in the first bulleted point, that it should enter in a similar manner. If it's a numerical one, still you will follow a similar pattern, like it should be either with 1 decimal, 2 decimal, or it's a full number. Always enter either an alphabet or a number in one cell of a master chart. So one box, in colloquial way if I have to say, one box, either it should be a number or a text variable. It should not be mix of two. Next, check the variable coding, because lot of softwares, they handle the data once we code them. So always check, and it is always suggested that we have a sheet that is called as data documentation sheet. So the data documentation sheet basically works on this. Like we have a list of all the variables, the name of the question, name of the variable, how the data is collected, in the sense whether it's a text or numerical, and what are the accepted fields. Like suppose gender is one variable, so we would be accepting male, female. Next column would be how they are coded. Maybe you can code male as 1, female as 2, so that when you actually code the data, you do not make any error. So these are certain do's of making a proper master chart. At the same time, there are certain don'ts of making a master chart. So one of the don'ts is never ever convert a numerical variable to categorical variable at the time of data entries. So just add the variable, like if you are collecting a continuous numbers, please add that age as a number or a numerical variable into your master chart. Maybe at the time of data analysis if required, you can convert this numerical variable to categorical variable. But do not do this step directly in the master child. Next, do not ever start name of a variable with a number. There are a lot many statistical analysis softwares which accept the accept the name of the variable if it starts with an alphabet. So if suppose you name a variable like one.name or one.gender, what software is going to do? Software is going to add an alphabet before that. A lot of time add or some symbol. So add one.gender. This would be name of the variable. And if you have so many different variables starting with a number, so imagine all your variables will be starting with add. So again you will have to make the change when you will be writing your results. So it's better to have a very clear, concise name of the variable. Another issue which I have found most of the time with the person who comes for data analysis is they make multiple master charts, like socio-demographic factors in one sheet of a master chart, then maybe some other characters in another sheet, maybe they have collected some data for third objective, that is another sheet. So please do not do this. The entire data for your entire study should be one sheet. It should not be extended, because when you use any statistical analysis software, it usually imports data from one sheet of a master chart. It does not merge 2-3 sheets together and run the analysis. These are some of the drawbacks of the master charts. Next is do not mention names of the variable in 2 rows. Lot of time what we do, we have this habit of mentioning, like a lot of people do, demographic variable, and below that they write sex, age, gender, all this data. So the problem with such data is, if you make variable into 2 or 3 rows, the softwares will take only first row as the variable name row. The rest all rows would be considered as sample data or your participant data. So you are again going to start with an error when you start your data analysis. So it's always better to have all the variables in one row. So these are certain do's and don'ts of making a master chart. The next step before we actually jump onto data analysis is we need to do data cleaning. So that's a very important step. We need to check first how many cases, how many controls, or how many intervention, how many comparator arms we have. So always review the number of observations which we have in our database. That is our first step. Check for any duplicates. Then always run your data analysis, or before you will go for data analysis, check if there are any variable or if any data is missing from a particular variable. Then check for the legal ranges and legal values. That is why I said a data documentation sheet would be most useful, because that data documentation sheet will very clearly specify us, like male will be coded as 1, female as 2, and if there is any missing data, either we need to find copy of the questionnaire or talk to the person who has collected the data, but just don't empirically enter any value if there is any data missing. You may exclude that particular data from the final analysis. So once this is done, once you have cleaned your data, yes, now you are ready to go for your data analysis. When we start with data analysis, we often run data analysis into 2 parts. So first part is we do a descriptive statistics, and this is inferential statistics. So descriptive statistics, as the word suggests, clearly description of the data. We just describe the data what we have collected. So we just summarize our finding, like in terms of demographic characters, maybe clinical symptoms of the patient, clinical profile, the expected outcome, and these data are often presented as simple tables or the graphs. So this is just the description of data. Categorical data one describes as percentages, and numerical data based on the distribution are often represented as mean plus minus standard deviation or median with interquartile range. So this is how we are just going to describe the data. This is a very essential step. This has to be done for any data analysis. So this is the most important step. You need to explain what kind of data you have, what kind of study population you have. So that's about the data analysis. analysis for descriptive. Coming to the inferential statistics. Now, inferential statistics, as the name suggests, it is deducing certain inference from the available data. So basically, we have to generalize the finding from our data to the larger population, which my previous speaker spoke about when he spoke about sample size calculation. So we just take a sample that is a subset of a larger population. So whatever our findings of the data or the sample are there will be applicable to the larger population. So it means here we are going to deduce certain inferences. So if we would be either doing the hypothesis testing, we would be checking the relations among the two variables, or we would be just generalizing our data from the sample to the population. So this part is basically about making predictions or generating inference. So coming to the first part, the descriptive statistics. As I have already told you, the descriptive statistics is the variables are getting described. Just describe the variable like frequency or summary statistics or the appropriate graphs but at the end, whenever we analyze the data for descriptive analysis, always check for the denominator. This is a good practice because it is going to help you to again check inadvertently if there is any missing entry or if there are any inadvertent data error, inadvertent error of data entry. So it is always better that whenever you run a descriptive data analysis, always check for the denominator, and the denominator should be equal to the sample for that particular research question. So this is one of the important steps in descriptive data analysis. Now coming to the next part, that is most important, which is inferential analysis. As I have already told you, this is the one which we most often look. Now where are we supposed to do our inferential data analysis? So whenever we are making a comparison between at least two groups, the two groups could be case control, the two groups could be the exposed and non-exposed in terms of a cohort study, the two groups could be the different two types in a analytical cross-sectional study, or it could be intervention arm and control arm, or it could be something else. So whenever there is a comparison between at least two groups, we would be running an inferential statistic. So whenever we do an inferential statistic, it is often based on a priori hypothesis. So what do I mean by this? A priori means it is decided before the data collection has started. So that is a priori. It is already decided when the protocol was framed. So it is based on a priori hypothesis that we have to test on hypothesis. If we find some observation and you want to check whether this observation holds true for your data, maybe in that case you have to make a comparison between two groups for the appropriate measure of association. Now the measure of association is always a confusion. What is measure of association? So the statistical test for significance of association I am going to deal today. There is something called as strength of association. Now the strength of association often expressed in terms of relative risk, odds ratio and the other risk ratio. So there is a difference between test of association and strength of association. So please be aware of this. And sometimes we do inferential data analysis based on our prior knowledge, maybe some literature we are aware of, or maybe our study design in such a manner that we definitely have to make a comparison between at least two groups. So these are the prerequisites that are giving us an idea when are we supposed to go for inferential data analysis. Now, whenever we do an inferential data analysis, there are certain steps to be followed. You would have heard, because of paucity of time, I cannot go into much of the detail, but I assume you would have heard something called as normal distribution. So whenever you are doing this hypothesis testing, always check the distribution of your variable, and I have specified as a numerical variable, because it is always that a numerical variable distribution to be checked. A categorical variable is always non-parametric or non-normal distribution. The test of significance which we would be using for normal distribution variable are called as parametric test, and the one which we would be non-normal distribution, we call them non-parametric. So these two we would be using. Then decide upon the test of significance that is to be applied. Next part would be select a desired p-value, which is often 0.05. But sometimes we can go beyond the value 0.05, we can choose 0.01 or we may choose 0.001. And once we calculate this, basically the last bulleted point is basically if you are doing the manual calculation. Because most of the software will give us the p-value and the significances. So these are certain steps in hypothesis testing. How do we decide upon the test to be applied? So again, I'm just going to restrict myself to the basic test. So imagine there are 4 situations which are in front of us. Like we have to test the difference between 2 groups which are unpaired. Now unpaired means the 2 groups are not directly related to each other. So if suppose we are doing a case control study, or if we are doing a cohort study, or if you are doing a 2-arm randomized control or 3-arm randomized control study. So all these groups are unpaired, or they are called paired. Then we may come across a situation where we are making a comparison between the same group, but the data is collected over a period of time. So the crux here is the participant acts as his own control. So maybe if you are collecting the data which is before and after, or we are collecting data which is a time series, maybe like a lot of time research in anesthesia is of this nature. Suppose SpO2 before induction, SpO2 immediately after induction, SpO2 after 2 minutes, after 5 minutes, after 1 hour, after 2 hours. So the same participant data is collected over a period of time. So that is a time series, or crossover, which is a type of a randomized control trial. If such situation is there, that's a paired scenario. So and then we have 2 more, agreement and association. So I'm just going to deal with each one of them in detail. So imagine first scenario that you have unpaired groups. So let's take an example. We have a case control study. So case and control are so that is the grouping variable. Now other variable of our interest is numerical in nature. Now we have to check the distribution of the variable. Now if the variable follows normal distribution, we would be applying a parametric test. And if it does not follow normal distribution, we will be going for a non-parametric test. But if you see, as I told earlier, for categorical variable, we did not check for distribution. That's why we directly go for the test of CME. Now in parametric, if suppose we have 2 groups like case and control, we would be using unpaired t-test or independent test. And if suppose we have more than 2 groups, so maybe like case, control, and there is one more control, or maybe one more category of cases. So there are 3 groups now. In that case, we would be going for an ANOVA. Remember, ANOVA will be always followed by a post hoc test. Similarly, if our variable is non-parametric in nature, for 2 groups we would be using man-Whitney test, and for more than 2 groups we would be using cross-Falco test. For categorical, it's very clear. So imagine case and control, the other variable is gender, which is again 2 groups. You will be applying chi-square test or Fisher's exact test. Fisher's exact test is a special test when the sample is very less. So there are 2 criteria for it. One of the criteria is this is theoretical, but we actually follow it. If more than 20% of the cell have expected cell value less than 5, we apply Fisher's test, or in a 2x2 table, if any observed value is 0, we apply Fisher's test. This is very simple. For more than 2 groups, we apply chi-square test. Similarly, if suppose we have our observations which are paired. So I have already dealt with this. The paired means it's before, after, over a period of time, or crossover type of RC. So this is how our grouping variable will look like, paired one. And then we have another variable which could be either a numerical or a category. If it's numerical, again we are going to check for the distribution of the variable. If it follows normal distribution, we will be applying a parametric test. If it doesn't, we will be applying a non-parametric. If it's a parametric for 2 groups, then we would be applying paired t-test. And if it is non-parametric for if it is parametric for more than 2 groups, we will be using a repeated measure ANOVA. Similarly, for non-parametric for 2 groups, it will be Rajkot test, and for more than 2 groups, it would be Friedman's test. Now imagine a categorical data. So I'll just give you an example of a categorical data. Imagine I am asking someone about a particular symptom which is categorical, like itching. So do you have itching? The answer is possible yes or no. So I have collected data, then maybe I gave them some treatment, imagine this, maybe an antihistaminic, and after giving an antihistaminic, I again ask them. And again I am going to get the response in the similar manner, yes or no. Now this has become a categorical paired data. So the previous data was categorical, similarly after data is static. Since the categorical data has only two groups, yes and no, I will be applying a maximum or stress. And if suppose it was something like yes, no and don't know or maybe. So if it is more than two groups, then I will be applying the Cochrane's Q test. So these were the test of significance for paired and unpaired data. Next is when we have to do agreement between assessments. Now what do I mean by agreement between assessments? When we have to check a screening test against a gold standard test, maybe if you have to do a rater validation between two individuals, like there are 100 X-rays, there are two individuals or two assessors, and they have to categorize the X-rays into whether the X-ray is diagnostic of pulmonary TB or non-diagnostic. And then at the end we are going to see how often these assessors agreed on it. In that case we have to check. So when we say assessment or agreement, either it would be of numerical data or would be of categorical data. If it is numerical data, so one graphical method which we would be using in our data analysis would be Bland-Deltman plot, and the other quantitative data analysis method which we could be using would be called intra-class correlation coefficient. Similarly, for categorical data, the example which I gave about X-ray chest for pulmonary TB and two assessments. That case would be applicable for, so in that case we will be applying a Cohen's-Kappa statistics, and if suppose the rater give rating on a ranking scale like 1, 2, 3, 4 like this, and if there are more than two raters, in that case we would be applying Kendall's coefficient of Concord. So these are the tests of significance for agreement between the assessment. Now coming to the most important part, that is association between two variables. So when I say two variables, it means either the variable both are numerical in nature or both are categorical. If both are numerical in nature, we need to check whether they follow both of them follow normal distribution or not. If either of them does not follow normal distribution, then we won't be able to apply a parametric test. So if both follows normal distribution for numerical variable, we will be applying Pearson's correlations, which is Pearson's R, and if any of them or either of them are not following normal distribution, then we will be applying Spearman's rho correlation or Spearman's correlation or Kendall's star. These are the association relationship between two variables. Now when it comes to a categorical variable, if it's a 2x2 data, we will be applying chi-square test and Fisher's test. Now this is but if it's an association between two variables, and if you found statistically significant association, don't ever hesitate to measure the strength of association, which would be odds ratio in case of a case control study or an analytical cross-sectional study, and it would be relative risk in when it's a cohort study or a study. If the data is more than 2x2 data, again we can apply chi-square. This is more often called as chi-square for a trend, or we can go for logistic association. So these are certain tests of significance which we can use when we have to check the relationship or association between two variables. So with this, I have concluded the basic part of the data analysis, how to decide upon the common test for data analysis. This would be my last slide. It is always better to use some software for data analysis rather than doing it manually, because certain tests are quite easy to do manually, but then it's very difficult when we have to analyze the data using, like when we do it manually. So software are there and they would be there. So learn some software for data analysis because they are going to save your time. Another thing is, if suppose there's a project going on, you have done the master data analysis as an interim analysis, and if suppose now you have some data has changed over a period of time, then again the same analysis can be, you need not have to do the analysis process. And it also helps you to rewrite a structured analysis according to the analysis plan, which won't be a haphazard in nature. I have just listed down certain software which are open access and freely available. You may have a look at them, and this is an endless list, so I have just listed down some very basic software. So with this, I thank you for your patient listening, and again, I thank organizers for giving me an opportunity to interact with you all. Thank you very much.
Very nice presentation. Can you mic चालू करो?
Good afternoon, sir. Am I audible?
Yes, sir, you are audible, sir.
So very nice presentation.
Hello.
So we have one query. Sir, can we adjust the statistical test based upon the data distribution, so regardless of what was mentioned in the study protocol before starting the study?
Yes, sir. Because when we write our protocol, we do not not aware how the data would be distributed. Maybe that is the reason we calculate sample size. Because sample size, if it's adequate in number, we may get a data which is normally distributed. So when we actually analyze the data, if the distribution does not follow normal distribution, it is always better to go for non-parametric.
So one more question, sir. How reliable are the statistical results generated through the Excel? There are formulas available in the Excel also. So are they reliable, sir?
Yes, the formula which are available in Excel are very useful, but there's one drawback. Excel doesn't give p-value. Excel doesn't give p-value. It means again you have to go to the critical table of p-value, check for that degree of distribution, and then get the p-value from the textbook or the standard tables, and then interpret your factor. That is one of the problem with Excel.
Thank you, sir. Nice question.
Thank you very much.
So one more question.
Hello, good afternoon, sir. Sir, you
Yeah.
said not to make multiple sheets of data, rather just make a single one. Sir, if you want to compare intra-group comparison of various tests, you want to apply tests within the same group. So how is it possible in a single sheet which has multiple groups?
Okay, so in that case, the software which you would be using for data analysis always give you an option for cases. Whichever if you go using R, either you are using SPSS or any other software.
It will give us an option.
Yes, it has options.
Okay.
So you can choose what data you want to analyze from the entire master chart, and you can just run that selected data analysis.
And sir, another question is when we enter the data, the variable names, and as you said, when we enter the variable names, there are different categories of entering the variables like numeric or like string character or nominal. So usually we are confused whether suppose name we know that it is a nominal. Then where should we apply string as a variable, and where should we
So,
apply?
okay, listening to your question, I assume that you are talking about SPSS software.
Yes.
So in SPSS, string means it means a categorical variable. String variable in SPSS is a categorical variable. It can be both nominal or can be ordinal.
So for ordinal data, we should choose string variable.
Yes, you can, but if suppose your ordinal data is numerical in nature, so when you code your data, you have to change the type of variable. So you get that list where numerical. Now string means if you have entered the data as alphabets, but moment you change those alphabets to numbers, you have to convert that string to numerical. Okay.
Thanks.
Thank you so much, sir. May I now request Dr. Mehul sir to present a memento on behalf of the institute. And I also request Dr. Arun Kumar sir to receive it on behalf of Dr. Yogesh. trainer in induction module for community health officers under Ayushman Bharat and national trainer by FSSAI and NHSRC for the Eat Right India toolkit for community health officers. Sir is national coordinator of National Center for Policy Research on Tobacco Control and Center for Policy Research and Data Analytics in Health and Environment. Sir has received IAPSM Presidential Award. His area of interest is community-based primary healthcare implementation research. Over to you, sir, Dr. U. Venkatesh.
Thank you so much. Very good evening, and this is the last presentation. So, first of all, I like to thank the organizers and especially Krupal Joshi sir for giving this opportunity. My session titled Writing a Research Proposal. So, I picked out two important objectives for this session. That is to understand the essential component of a research proposal using standard format. Secondly, apply proposal writing skills through a case study of ICMR extramural research proposal, where I will be telling you, based upon my experience, that within last 3 years able to get 6 extramural grant. So starting with the essential components of the research grant. So before this components, I want to tell you that having a good team is very important. Suppose even a new researcher want to do submit a proposal for a grant. If you are having a good team where the co-investigators are experienced and have demonstrated some expertise in this field, then that will be helpful. So having or finding a good team is very important for any research proposal. So we're starting with the title. This is a recommended and generally accepted that the title should be concise and specific, and title should be informative enough, and it should be representative of the entire manuscript, and it also should indicate the study design. Even if it is the exact study design is not mentioned in the study, that is also okay, but it should give some indication regarding the study design. Then comes to the abstract. I have kept the second number, but it usually is written when you completed all the parts of the proposal, or you can rewrite the abstract at the end, and it is generally kept within 150 to 300 words. Then comes to the introduction. The introduction, it should be a sufficient introduction should be there, and sufficient the problem statement should be there, and also highlighting the uncertainty with the help of good review of literature is important, and thereby you can actually point out some of the important justification and rationality of the study. Then come to the research objective and the research question. And for the research objective, we generally use the SMART criteria. That is, S stands for specific, M for measurable, A for achievable, and R for relevant, and the time bound. That ensure that the research objectives are well defined, and we always use actionable verb. For example, to assess, to find, to compare. The objectives start with the actionable verb. Then we also focus on the measurable outcomes. As far as the research question is concerned, we use PICO format, or we can say PICO. PICO framework is generally accepted for an analytical studies. Then come to the methodology. Detailed plan of how the research will be conducted, that should be well written, and generally the methodology are exhaustive in a good proposal. But sometimes nowadays the funding agencies keep the word limits to it. So we need to be careful, at the same time detail as much as possible. Then the timeline. The timeline should be realistic, and generally whether it is your institutional ethics committee or a research advisory cell, they actually demand the Gantt chart. So where you will have a month-wise activities for a duration of the
period of the study. Then the ethical statement should be there in the proposal. This is very important. Along with the patient information sheet, consent form, you should also have the questionnaire also, because the questionnaire will be also reviewed by the ethical committee. They will also see whether these questions are acceptable to the community or not, if it is a questionnaire based study. Then comes to the expected outcomes. The expected outcomes should be measurable and observed outcome should be there. Observable outcome should be there. And we need to also align this outcome with the contribution to the future research, how this findings actually contribute to the future research. Then the budget. Budget is often ignored, but we spend most of the time in designing the methodology. And in the last date of the submission, we actually review the budget. But this is often a mistake. We have to actually allocate time for non-technical things like budget, expected outcome, rationality of the study. I will highlight all those points in the upcoming slides. So this is the standard, the framework which generally followed. Here I just want to focus on the introduction, research and the methodology. Then rest of the things I will take care in the upcoming slides. As you can see here also, the context should be sufficiently explained, and the problem statement, the problem analysis, including the brief review of literature. Sometimes when you are submitting for the institutional review, they ask for the separate review of literature with the appropriate and appropriate references. But nowadays, when you are reporting your proposal into a journal, we generally go for a brief review. You can add many references with those texts. Then comes to the research question. Like I already said, the PCOT is the framework which we follow for the research question, and we have to devise the objective with the help of the SMART, with the help of the verb. Then come to the methods. Methods include the study setting, the study design, study population, the sampling size, the data variables, and sometimes people ask separately what are the independent variables, what is the dependent variables, what are the additional variables that can be also listed out in the proposal. Then how you going to collect the data and what is the validation process. If you are using any study tool, you have to also add the details about the study tool, and also some of the validation of those tools also needs to be mentioned there in the proposal. Then the data management and the data analysis plan. It is not necessary to have the data dummy tables and figures, but you need to have a clear plan. That is very important, and that plan should actually align with the study outcomes. Then comes to the ethical consideration. It includes a review and approval from that ethics review committee statement should be there. The permission to assess the data from the other authorities is very important. It is not that you got a research IEC approval, then you started to collect data from anywhere. You need to have necessary permission from the competent authority. That is very important. Then the consent form should be there along with the PAS. Then how you going to safeguard the data, that is confidentiality, how you going to maintain the confidentiality, that statement should be clearly written. And dissemination plans and stakeholders engagement statement may be added in case of the implementation research. Then you can also have the study outcomes in the form of implication, the future implication on policy and the practices. Then we have some other subheadings like project management. Roles and responsibility of each investigator should be clearly defined. Whether it is a study design, whether it's a study protocol, whether what will be the role of the particular co-investigator in the data collection, data entry, data analysis, drafting the first manuscript, critical review of the manuscript, until the review completes. What will be the role, different roles and responsibility of the team should be clearly defined. Similarly, the project timelines, I already said that in the form of Gantt chart. Budget, there is not a clear guideline for every funding agency have their own guidelines. So before designing a budget, it is advisable to read the guidelines of a particular call for proposal. So whether the budget is okay, then you need to also have a justification statement. That is, the budget narrative should be also there. So this how actually you can come up with designing the introduction part, where you have to start with the broad research areas and end up with the clear the research focus. So I just want to focus on the key aspects of the proposal, considering the time limitation. So let's come to the P code. So P code stands for population or a problem. In case of it, it's a non-descriptive study or cross-sectional study. So P stands for population, I stands for intervention, and E, suppose if it is a observational study, then the C stands for comparison, and O stands for outcome, and T is the time period. With the time period, the outcome may change. The outcome which we get in 1 year may be different from different at the end of the second year. So the outcome, the time period also should be mentioned. So we can say as a P code format. Let's take an example. Suppose this is the research question. How do HIV infected tuberculosis patients fare with early antiretroviral treatment? So if you use the P code format, then just write down this. The P here is the HIV infected tuberculosis patients. I is the early ART. We have to also define what do you mean by early ART. Early ART, that is here they have defined in the first 2 weeks of initiating the tuberculosis treatment. Then C is the comparator. Comparator is in comparison to the late ART. That is, late ART is after 2 months of initiating the tuberculosis treatment. Then O is the tuberculosis treatment outcomes. The outcome may be cure or a treatment completion or a death or loss of follow failure, that needs to be defined. Then the time. So if you revise this original research question, now this research questions read like, among HIV infected tuberculosis patient, does offering early ART during the tuberculosis treatment improves treatment outcomes compared to the late ART? Now this question is actually improved, making the research question clear and measurable. So that's how you need to improve your writing. Now since yesterday you are reading about the study design, study setting, study population, I am not going to in detail, but these are the statements which needs to be there in your study protocol. We will discuss the methodology in the upcoming slides. So similarly, the sampling methods. Suppose if you are having a flow chart or a flow diagram demonstrating the sampling the methods, then it will be very useful. Similarly, the sample size. Ultimately, you have to generalize the findings from the sample to the whole population. So the appropriate sample size, that is very important, that should be there in the protocol. Next comes to some of the standard protocol, the checklists which are available. As many of you know, there are reporting guidelines which are available. For example, for reporting a randomized controlled trial, we have a checklist called consort. Similarly, for the observational study, we have a guideline called strobe. For a systematic review, we got the Prismo. Similarly, we have the checklist for the study protocol reporting also. So you can download these protocols. There are various checklists available, but as you can see in my slides, there are 639 reporting guidelines which are available in the Equator network. So how to visit this website? You have to log in into the www.equator-network.org. So the Equator stands for Enhancing the Quality and Transparency of the Health Research. So there are checklists, different kind of checklists available. This is your one-stop shop for writing and publishing high-impact health research. So where you can actually find out the suitable checklist for your study design. So if you are going to report the study protocols, so you can see here, you can see search for reporting guidelines tab is there. If you click this, then you will actually find a drop down menu where you can choose study protocol. If you choose, currently there are 28 different kind of protocol checklists are available. It may be for the qualitative study, it may be for the sensitivity or specificity study, or it may be for the intervention study. So the guideline which I am going to discuss today is the SPRIT 2013 statement. The SPRIT stands for the Standard Protocol Items Recommendation for Intervention Trials. Okay, so this is a common protocol checklist which is available. Even I have seen many of the research advisory committee in the institute also follows the SPRIT guidelines. So if it is a non-interventional study, you can skip some of the part also. This is a checklist. It is a standard checklist which is widely followed. As you can see, what are the things comes under the introduction? That is background, rationality, and which we already discussed. Then the objectives, the specific objective or hypothesis, that should be also comes in the introduction part itself. Also the mention of the study should design in the introduction. Then comes to the methodology, which includes the participant, intervention and study outcomes. Under this heading, what are the things coming? Study design. So you need to report whether the study setting is the community or the hospital-based study. And if it is a multi-centered study, you need to also list out what are those study sites. And you need to also mention what are the data sources also. When it comes to the eligibility criteria for the participants of the study. If it is a multi-centered study, you need to also mention that what is the rationality behind choosing that particular study centers. So that is also sometimes important. Then comes to the intervention. As far as the intervention is concerned, if you go to the Equator network, there are various checklists available in specifically reporting the intervention. You need to report intervention in the particular the checklist. As you can see here, the 11A actually intervention for each group with the sufficient details to allow replication. So in order to replicate the intervention, you need to have detailed intervention in the proposal. So I will introduce some of the tools of reporting intervention in the upcoming slides. Then comes to the outcomes, whether it is a primary, secondary or other outcomes should be clearly defined, and what is the method of aggregations that should be clearly mentioned in the protocol. Then comes to the participant timeline, and here preferably the SPRIT 2013 statement recommend a schematic diagram. Then the sample size. Then the recruitment, the strategies for achieving adequate participant enrollment to reach the target sample size is important. Similarly, if it is the randomized control trial, the allocation, the sequence generation needs to be clearly defined, which participants will go into the control group or which participant will fall into the intervention group. That should be clearly mentioned. Then the allocation concealment, we need to prevent the awareness of the study treatment. Then we need to also take care of the allocation concealment mechanism. Then the blinding is also important. In some studies, the blinding may not be possible. In the study, where the study blinding is possible, you need to mention what kind of blinding it is. Then the data collection methods, data management plan should be adequately written. How you going to address the missing data? How you going to address some multiple entries? Those plans should be there in the proposal. Similarly, like it was stated in the last session, the statistical method should be clearly described in any protocol. In fact, the statistical methods is very important for achieving the access to the data. All those things to be there, including the questionnaire. If you are collecting the biological specimen, then those plans should be there in the protocol. Or this how your protocol will be reviewed if you are publishing the protocol. Even it is followed by many of the funding agencies also. So now I am introducing another tool called TIDEA, that is Template for Intervention, Description and Replication Checklist. This is a checklist basically for the intervention description. So as you can see, you can actually name the intervention with the help of a brief name also. So brief name can be provided for that intervention. And then the second point is the why, that is describe any rationality or a theory or the goal of elements essential to the intervention should be there. Then what material, describe any physical or information material used in the intervention, including those provided to the participants or used in the intervention delivery. Then the procedure, and who provided this, how, then where, describe the types of location where the intervention occurred, and including any necessary infrastructure or the relevant features. Then when, describe the number of times the intervention was delivered and how much, over the what period of time, including the number of sessions, the schedule, the duration, the intensity or a dose should be there. Then the tailoring, if the intervention was planned to tailoring or customized, then that, and what, why and when and how it is done, this statement should be there. Then if the modification is done during the study, that also needs to be mentioned, what modification is done, why it is done and when and how. Then how well they are planning, if the intervention adherence or fidelity was assessed, describe how, by whom, if any strategies were used to maintain or improve fidelity, describe them. That needs to be there. So this is the checklist, useful checklist. You have this checklist when you are describing the intervention in the proposal. Then come to our second objective, that is taking a case study of the ICMR. So the points which I am going to tell you, this is not only for the ICMR, this is for many of the funding agencies. If you are targeting, you can also target some international grant like NIH or any other grant also. So these are the things which I follow. And as far as this ICMR tips is concerned, I presented in front of ICMR officials also. They also agreed upon. So which you can also maximize your getting the grants. So first one is, you need to follow that the funding agencies which you are targeting, for which you are writing the research proposal. Suppose it is ICMR, follow the ICMR media, the social media, and stay updated with the every updates. How this can be useful, I will tell you in the upcoming slides. Then reading the every line of the call for proposal is important. Sometimes the research question will be hiding in this proposal. So you read out every line of the proposal. Okay, that is very important. The third point is, you have to also understand the administrative setup of the funding agencies and how this different division works. If you go to the ICMR website, you can actually see the organogram of the ICMR and different divisions under the each administrative setup. This will actually help you in getting the multiple grants in the calls. Then submitting the multiple proposals. See, if you want to take a wicket of a batsman, if you ball one ball, then the chances of getting out is less. If you ball two, then it increases. Similarly, three. If you are submitting 6 balls in a 1 over, getting a wicket will be comparatively easy as compared to bowling 1 ball. So to understand that, try to submit multiple proposals. Then the most important thing is, you understood the administrative setup and the division. Now submit the multiple proposal in the multiple division. That is very important. There are many divisions that, suppose you may say, no, I work in a particular area only. Suppose you are an anemia expert. So you can see the anemia can be, proposal can be submitted in the nutrition division also. The anemia proposal can be submitted in the neurological condition if you are associating anemia with the cognitive decline. So that's how you can actually strategize this proposal. If you submit all the 5 proposals into one division, you will end up with maximum 1 proposal getting selected from the call. So if you are submitting multiple division, then you can actually get the chances of getting selected the multiple proposal. Then comes to the taking snapshots of application form pages. See, the ICMR and many other agencies actually follows the online submission. Okay, so since the month or 2 month, you keep on writing all those things with big methodology and all those the components of the research proposal. At the end of this, at the time of the submission you open, suppose it is the last day or 2 days before, when you open the pages, the things will be different. The questions which are asked in the form will be different from the components which you are having. So every year the form changes. Some modification actually occurs. But the standard format I already told you. So what you try to do is, you log in, create an account, and suppose if you look at the ICMR forms, you need to fill up some pages. You need to upload some pages so that you can move into the next page. So what you do is, fill some random information, some random text. Just upload some random documents and go to the next page and take a snapshot. Similarly, you need to take care of. Then you need to also focus on the non-technical details, and the non-technical details which also include the expected outcomes, rationality, the institutional support, prior experience. All those things are also important. What people used to do is, entire 90% of the effort they used to do for methodology, designing the good designing or the sampling strategies, some innovative analysis. All those are good, but also you need to also take care of the budget. You need to also care of the writing part also. You need to you need to articulate in such a manner that it actually comes in the priority area of the research of the ICMR. I will tell you how to find out the research, the priority areas of the ICMR. Then highlighting the institutional support. This is also important. What are the ways your institute actually play an important role? It may be with the help of the equipment, with the help of the space, with the help of the manpower. That is also important. Similarly, you need to take care of word limit, for that you can actually use AI. So keep AI with you, and if you end up with writing 1000 words of methodology, with the help of AI, actually you short down under the different headings. Similarly, if you are not able to accommodate in the text, then it is better to have the flow chart and Gantt chart. See, I am telling you, it is one of the important tips. If you are having good flow chart and Gantt chart, you are maximizing your the chances of selecting for the grant. So there will be an option called additional document uploading additional documents, where you can actually upload flow chart and Gantt charts. So you prepare very beautiful diagram, flow chart, all those things. Actually, it helps and it helps to understand your proposal in a shorter time for a reviewer, because a reviewer get very less time for reviewing your proposal. Within the short span of time, he need to make a decision. He or a team. Generally, in ICMR, the protocol is presented. They used to conduct a meeting, a roundtable meeting where the proposal are presented and the different experts are sitting. So that's how they need to take the decision in very short time. Then the budget preparation, it is very important. You read out all the ICMR guidelines, you download ICMR extramural the guidelines, then only you can make out some idea. Suppose you designed a study for 3 years and it is a multi-centric study, and the capping of this budget is 2 crores. When you actually enter all those things, you end up by creating budget more than 2 crores. It is 5 crores your budget is coming. So the last minute POs will happen. So what happens if you are not reading the salary patterns of different manpower, you will end up with a poor budget. Then it will be a problem for you while completing the research project. So always read the budget part, very important. And that is why I said take snapshot of all the pages and carefully design the budget. It's a multi-centric study. If it is a single-centric study, then also you will be able to manage. If it is a multi-centric study, you have to be very careful with while designing the budget part. Then coming to the last, don't wait for the last date. Many times the website crash or something not working, you need to have to mail or something, that kind of problem can occur. So try to submit as soon as possible. Then complete your research profile. If you create an account in the EPMS of ICMR, you complete your profile. People just upload the photographs and basic details and just submit a photograph. No. Actually, when this PDF is made, PDF is sent to the reviewers, it will come along with your complete profile, which include the publication, grant received, experience details, everything. So sometimes, apart from the scientific content of the proposal, budget, sometimes people also see the institution. also see the researcher experience, prior work. All those things are very important. So complete all those things and spend time beforehand. Then, as you can see, this is the 2013 actually call. As you can see, you have to read out every point. See, the proposal needs to be well circumscribed, time bound, and it should achieve specific and measurable objective and should be aligned with the ICMR priorities. What are the ICMR priorities? You need to understand this. Currently, they are dividing this research into descriptive research, delivery research, development research, and the discovery research. Descriptive research is basically descriptive in nature, where suppose you want to see the prevalence or some type of cross-sectional study. The delivery research is basically the implementation research. So suppose you are coming with some, you found out some gaps in the programs which you want to improve the outcome of the program. Those kind of studies will come under the delivery research. Then come to the development research. The development research, that is the development of any screening tools or the diagnostic techniques or any other techniques you want to develop. Those kind of things will come under the development research. The discovery research is basically finding some novel intervention. For example, the preclinical or phase 1 studies comes under the discovery research. Now, coming to the next slides. See, I told you in the beginning, you need to follow the social media updates of the ICMR. See, this is one of the social media posts where they had 2 posts and they had some caption on it. Now you see, observe this. So they also used to conduct governing council meeting. They need to also conduct some approvals. So they need to also meet some of the goals. See, we have sustainable development goals where the world leaders meet and decide to work on some particular issues. So when it comes to health, there are some of the disease where we need to improve our fundings. So those things you can have an idea from these updates. Now observe these meetings. See, as you can see, the director is actually briefing to the health minister, and there is a slide in it. So zoom this slide. As you can see, the focus area of ICMR is changing. Earlier, the research proposal which were approved, 70% falls under the descriptive part. The others are the delivery, developmental, and the discovery. Now they are actually going to change this distribution, and they have reduced the description part from 70 to the 30 or 40, 30%. Now see, 40% reduction in the descriptive. So what you need to do, you need to focus on the other developmental or a delivery research or a discovery research. So if you are come up with any descriptive research question or descriptive objective, then it will be you will have a less chance of getting selected. So suppose if you are having a descriptive study, then it should be a pan-India. Suppose you want to find out some prevalence across the nation. You want to do an assessment, for example, health technology assessment across the nation. And those kind of study, maybe the proposal may be selected. But that the institute also plays a role. Which institution is conducting that pan-India study, that is also important. So you will be having less chance if you are putting your research protocol in the descriptive. So you concentrate on other 3 points. Then what are the priorities areas? Every year, any funding agency like ICMR releases the priorities areas. If you see what are the priorities areas in the previous call, you can find out what very small changes will be there in the coming years. So identify those. See, the specific disease name is written: diabetes, stillbirth, postnatal care, endometriosis. Try to do something which the nation needs. Contribute to the nation needs. So they have pre-identified the diseases. So you hit on those areas. So if you ball on those areas, then only you can actually get the wickets. If you are having some pre-designed research question which doesn't fall under the priorities areas, of course you will be having the lesser chance. So while writing the research proposal, you keep in this keep this in the mind. So the duration of the project is usually, there are two kinds of external funding currently provided by the ICMR. That is small grant, that is for up to 2 crores, and as far as the intermediate is concerned, it is for 8 crores. If you go to Center for Advance, it is for 15 crores. So you need to understand the budget capping. This will actually help you in designing the study also. So understanding the budget capping, actually it will help you designing the study. How many sites you can include, what are the things you can accommodate, what are the resources you can actually mention in the proposal. All those things comes if you read those parts. Then maximum 3 years duration needs to occur. So you need to get those outcomes. Will you be able to see those outcomes within the 3 years? So that is very important. Right? Design the studies accordingly. So all you need to also understand now for the research institution, it is having high chance, because for this external research, the ICMR scientists are not eligible. Now they are having a separate cost. So this will actually, so firstly, for getting a grant, you should start writing the research proposal. Start writing a non-funded research proposal. Then you can go for the funded research proposal as well. Then you can have updates. Now recently the ICMR website has also been changed now. So now you can, at the top of the website, you can get all those updates. Then ICMR also have a special EPMS website for the electronic project management system. So create account on this and try to submit a proposal anytime. So see, adult learning is all about learning by doing. So you see, attending some seminar or something else will not make you to enable all those things. You have to submit. Right, in every process you will learn something. Small things will be there which you will learn. And this is the website which I wanted to show, where you can create the things, where actually you can actually fill out all those results. Now you're coming to the very important slides. I'm telling you. Now see how the scoring. Look at the scorings. You need to at least have 60 scores to move your proposal into the project review committee. So before going to the PRG, you need to have 60 marks. So how to attain 60 marks? You look at the things. I told you in the initial part, you need to also focus on the non-technical part. Now, you cannot say completely non-technical. It's less technical as compared to the other thing. Now look at this. The rationality of the project. Is it likely to solve a priority problem which carries 20 marks? Do we require research methodology knowledge in it? No. 20 marks. Then the second question is possible impact. Is it likely to have impact on health outcomes? 20 marks. Do we need research methodology knowledge in this? No. Comes to the novelty or innovation. Is the study developing or testing a new idea? Is 20 marks. Do you need research methodology knowledge in this? No. 60 marks. You attain the 60 marks which is necessary to go for the PRG. Then you also work up for methodology. Now you attended this research methodology workshop. Now you can actually have 20 marks from the methodology. Then implementation strategy. It is also relatively a technical. You can say 40% marks is actually a technical. The 60% is a non-technical part. So the project receive that 60 marks will be shortlisted for the review. So this is very important. So writing a proposal for a non-funding study or trying for a funding project, it is relatively little different. The research format may change. So if you look at the research format of ICMR, these are the research format. The majority of things are same. You need to take care of word limits. You need to take care of certain small questions prepared, pre-designed. For example, the title of the proposed research project. It should be specific, concise and descriptive. This is what we discussed in the earlier. It should be up to 25 words. Even if you try for lesser words. Then the summary. Summary, you try to fill this at the end of the proposal. You write something and try to reframe this at the end of the proposal. Then the priorities areas you have to choose. There will be a drop-down menu where you have to choose whether it's communicable, non-communicable, or the maternal and the child health care. Okay, this needs to be decided first. Then you have to tick whether it is fall under descriptive, discovery, development, and delivery. Now you know they are strongly discouraging for the descriptive part. So you have to devise a research question for the other three types. So you keep in this mind. Similarly, the keywords are important. Then the abbreviation list will be asked, that also you needs to fill. Problem statement will be there. The problem statement, it carries 500 words. It is huge. 500 words for the problem statement. Use this 500 words. Bring some uncertainty with the help of literature also. So this 500 words can be easily written. Then the rationality of the study, it is 250 words. See, in total 750 words, you can actually come up with the scientific knowledge, technical capabilities or the practice. Then comes to the research question or the hypothesis. You will get just 100 words. So with the help of, suppose you come up with 150 words, with the help of AI, try to reduce it. Then review that research question carefully. Then study objectives. Try to limit 3 or maximum you will get 4 columns for writing the objective. There will be maximum 4 column only. Try to limit with 3 objectives. My recommendation is define primary and secondary objectives if necessary, because the primary objective, according to the primary objective only, the entire methodology will be there. The sample size will be calculated on the basis of only primary methodology. Study design will be according to the primary methodology only. So you said that the methodology, I told you that going to the different pages of the grant submission form, taking a snapshot. Why it is important? Because as you can see in the call for proposal, this format is mentioned. Here you can see it is study design, study site methods for the entire study. But when you open the protocol submission, for every objective they will ask this headings. For the first objective they will ask study design, study site methods, sample size. For the second objective they will ask the separate sample size. For the third objective. So you need to, that is why I said, on the first day of the call itself or in the first week of the call itself, open the website and take out the snapshot of all the pages, and accordingly you start prepare the protocols. Then expected outcomes of deliveries. These are 100 words, 100 golden words. This is very important. Aligned with the research question. 100 words is most important. This will decide the selection of your the proposal. Very important. Then the future plan based upon the expected outcomes. It is important. Then other than also, you will find some small questions. See, if you open this, there will be institutional support column will be there. If you open this prior experience in the area of research question area, that will be also. So open all those things. There will be uploading option for the Gantt chart. Prepare Gantt chart and submit those Gantt chart. So with this, I am ending this presentation. If you have any questions.
Thank you so much, sir, for this informative presentation. Now, I request Professor Dr. Colonel Ashwini Agrawal, sir, to present a memento on behalf of the Institute, and I also request Dr. Krupal Joshi to receive it on behalf of Dr. U. Venkatesh.
Thank you, Dr. Venkatesh. Can you hear us?
Yes, sir. Yes, sir. I can.
You are the last batsman, but you kept us glued to the screen. Very informative session, and we are receiving all appreciation in our chat box. Thank you very much.
Thank you, sir. Thank you.
This is small token of appreciation from our side, which we will dispatch to you. Dr. Kripal is receiving it on your behalf.
Thank you, sir. Thank you, entire organizing team of AIIMS Rajkot. Many congratulations.
Thank you very much.
Thank you, sir.
And we will keep troubling you for our proposals if required.
Sure, sir. Sure. Definitely.
Thank you.
Thank you. Thank you, sir.
Lastly, I invite Dr. Krupal Joshi, Associate Dean Research, to deliver the vote of thanks.
Good evening, Honorable Patron, Organizing Chairperson, Distinguished Speaker, and dear participants. As we conclude this insightful 2-day CMEs on research methodology, it's my privilege to offer a vote of thanks. First, I extend my sincere gratitude to our Executive Director, Sir Professor Dr. Colonel C.D.S. Katot, sir, for his constant support and guidance, which were crucial in making this event success. Your inspiring leadership motivates us all. I also wish thanks to our organizing chairperson, Professor Dr. Ashwini Agrawal, sir, who is doing research and who is the main brain behind this CME, for leading such as remarkable events. A heartfelt thanks to our distinguished speaker, Dr. Umesh Kapil sir, Dr. Animesh, Dr. Dubjyoti, Dr. Archisman, Dr. Ankit, Dr. Vijay Gedha, Dr. Amit, Dr. Yogesh, Dr. Pradeep Agrawal, and lastly my dear friend Dr. U. Venkatesh. Your expertise and thoughtful presentation enriched this CME, providing valuable insights into the research methodology. We are pleased to share that this CME attracted overwhelming response with more than 3,000 registrations all over the world. Reflecting the great interest in improving the research skills, we are confident that the knowledge shared by our research person will inspire all participants to enhance their research contribution. I would like to thank all participants for your active involvement. We hope this CME is given you useful tool for your academic and your professional journeys. Special thanks to Eco Platform, our scientific and stage management committees for your hard work ensuring the smooth execution of these events. Lastly, I would like to extend my gratitude to our whole administrative staff of AIIMS Rajkot, technical team and volunteers who have worked tirelessly behind the scenes to make these events success. I extend my best wishes to each of you in your future endeavors and look forward to witnessing the application of the knowledge gained in this CME within your respective fields. Thank you once again. Have a great evening ahead.
Recording stopped.